discussed here today, the world desperately needs the critical solutions to the climate and sustainability challenges that SRI is dedicated to providing. I was fortunate to attend SRI 24 in Helsinki, Finland, and the sense of urgency, determination, and optimism there was energizing, and we want and seek to build on that. It was incredible. Hundreds and hundreds of the world's brightest minds gathered in one place, unified in the certainty that we absolutely must act, but also that we have within us all that we need to meet many of these technological challenges and societal challenges. That's real power, and I think this axis of collaboration with the Midwest and Mexico can be very instrumental in building that power base. So I hope you can join us in Chicago in June. And I'm excited by a similar sense of optimism and the can-do spirit here today. This symposium is drawing researchers from multiple Mexican states and from each of our 3 universities, Urbana-Champaign, Chicago, and Springfield. I'm also glad that the leader of our research park in Urbana-Champaign, the Executive Director and Assistant Vice Chancellor for Innovation, Laura Apenzella, is with us today. Thank you, Laura, for being here. The research park is a hub for innovation and a commercialization of the solutions it drives. And like DPI, it can be home away from home from all of you from Mexico. Looking at the roster of presentations, you can see the seeds of important collaborations that will be planted here: agriculture, nutrition, economic development, campus-level sustainability planning, to name just a few. And I'm incredibly excited to help open this symposium and see the connections and ideas begin to flow. Now, it's my privilege to introduce Dr. William Lee Alardin. He is, as I mentioned, Coordinator of Relations and International Affairs at UNAM, and he's got a wonderful backdrop on his Zoom presence, which I always somewhat jealous about, but it's so magnificent. A renowned astronomer, we share some of the same interests in space sciences, graduating from UNAM with an undergraduate degree in physics, like I did, before earning master's and doctoral degrees in physics from Wisconsin. He's been a researcher at UNAM's Institute of Astronomy since 2006 and has served as coordinator of scientific research at UNAM and secretary of the Mexican Academy of Sciences. Thank you for your leadership and your generous collaborative spirit, William, that you've always brought to the table. It's an honor to have you with us today, and I'm delighted to yield the virtual microphone to you.
Good morning, everyone. Thank you so much for your kind words, President Kalin, and to everyone for attending. I would like to thank President Kalin and the University of Illinois system and I-MMÁS and all the wonderful team that you have put together for this invitation, this organization, and this leadership around these topics that are so relevant for every one of us. I would like to transmit as well greetings from our rector, Dr. Leonardo Lomelí, and it's a pleasure as well to see my colleagues from Tecnológico de Monterrey, Universidad Autónoma de Querétaro, and UNAM, and more, of course. I am really very excited to participate in collaborations with the University of Illinois system. Over the past few years, I've had the opportunity to work directly with many of you, and we have consolidated an existing partnership because there are obviously channels that are open before any of this came about. But it's important to consolidate them and give them an institutional support framework to have even better outcomes. So these partnerships and collaborations have been around goals that are common in our mission as universities and institutions of research in education, research itself, generation of knowledge, public outreach, and the generation of public policy recommendations for the betterment of society. Many of these initiatives clearly are centered around sustainability. That has been our goal in each institution individually and independently, of course, but together we can do more. I have no doubt about that. These issues are also inherently multidisciplinary. They involve, of course, engineering, but they also involve environmental science, physical sciences, biological sciences, social issues, legal issues, and particularly, as I mentioned, governmental planning and public policy recommendations. We can't just do all this work and have it not be put in the hands of people who are actually making decisions for a better future. So I think this is a very important element of our discussions and our framework for how we think about these problems, how we make our outreach towards the outside of academia. It is also at the heart of keeping our communication channels open between institutions of academic objectives and opening others outside of academia, obviously, particularly at a time of tensions which are global. Some of them are more regionalized than others, but they're in general global, and they obviously tend to work in the opposite direction of opening channels. So we have to work probably twice as hard to keep these channels open and to make others available for other people. We are really very pleased to have developed, for example, a number of joint calls for proposals, which are already leading to interesting results and further preparation of ideas and initiatives for further collaboration around these topics. A lot of the effort that we have done is indeed centered around sustainability in many ways, and I think this has been of great consequence. We are also delighted to be doing this to enhance the participation of the Mexican community in sustainable initiatives and of the role that our school and branch in Chicago, UNAM Chicago, nuestra escuela, is playing in these collaborations. UNAM has made and is making a renewed effort to contribute to the development of the community of Mexican heritage abroad in the widest possible sense. And we have discussed this with your team, President Kalin, many times, and during our visits to Chicago and your visits to UNAM. And I can tell you how happy we are to have you as a partner in this set of shared objectives. And yes, I guess it's in the stars. We have something close to our heart there. So thank you all again. I'm certain this will be a wonderful meeting leading to further collaborations. And I'm very pleased to be a part of this. And thank all the participants for their contributions and their discussions and their thoughts that will lead to many results. And I am now very happy to introduce and give the floor to Dr. Julio Noriega Velasco, who is Internal Dean of the School of Engineering and Sciences at Instituto Tecnológico de Monterrey, a leading institution in Mexico as well. Thank you so much.
Thank you very much for the kind introduction, Dr. Leah Lardin. Dear Sylvia, I am extremely honored and grateful for the invitation and the opportunity to share a few words on behalf of my enthusiastic and committed community at Tec de Monterrey. I am pleasantly surprised to find a strong bond between our scientific communities. When visiting the I-MMÁS webpage, I found collaborations of scientists from all the institutions that we are present today here. Without a doubt, we must grow this collaboration. Dr. Timothy Killing receives our recognition for decisively promoting rapprochement initiatives between our communities, for promoting research and innovation, and especially for doing so in perhaps the most important issue that should maintain our attention as humanity, which is sustainability. I also appreciate the work of Dr. William Leah Lardin from UNAM, an institution with which our community of scientists collaborates strongly in some disciplines, and an institution with which we have very relevant research collaboration agreements. Likewise, I am pleased to greet Dr. Silvia Lorena Amaya, President of the Autonomous University of Querétaro, with whom we are talking to also establish a collaboration agreement in topics of great affinity and within which innovation for sustainability is part. In 1993, the UNESCO launched the World Science Report series. Since then, the UNESCO has published 7 reports. The last UNESCO Science Report was published in June 2021, and it reveals that countries of all incomes and levels share a common agenda for transitioning to digital and green economies. The report is a clear statement that the 2 biggest trends in the world are digitalization and sustainability. We have an enormous challenge that we could characterize with difference according to the region of the world in which we focus on, and also according to the industry or sector that we observe. However, there are coincidences where we can work together, and also only by working together we can add our capabilities and talents to develop better solutions. I congratulate all participants in this symposium, and I wish your experience will be memorable with memorable discussions. Before ending my intervention, I will share with you a reflection about the 2030 vision of Tecnológico de Monterrey that is strongly intertwined with the commitment we all have to sustainability and our aspirations for fulfillment as human beings. Our vision towards 2030 is leadership, innovation, and entrepreneurship for human flourishing. Human flourishing is a personal and a conscious process of capacity development in all areas of our life, in which each person relates to the community and the environment to create a better world. Respecting the dignity of people and all aspects of nature around us. What does this mean? It means aspiring to be well throughout the journey of our lives. Good on our own terms, and developing the capability to understand that all experiences are valuable and we learn from all of them. It means recognizing that we live in interdependence. What we do, no matter how small it may seem, impacts all people and nature in our planet. Therefore, reflecting before acting, and when acting, thinking about our environment and those around us is the basis for flourishing in community. Human flourishing is being aware that the future we dream of will only take place if the world in which we live also flourishes. Nature flourishes, then taking care of our world is being responsible for our impact, and persevering in sustainability is essential to promote the plenitude of the earth. Human flourishing is being in balance and seeking to live a good life of care and respect for others and nature. It's being committed and participant in the integral development of the community and our environment. It's living in harmony with nature and respecting all forms of life that inhabit it. Human flourishing is being a better person who improves the community and improves its planet. This is the aspiration we have, to educate leaders who flourishes as human beings, but to do so, we must flourish with our community and our planet. So discovering, designing, and creating new technologies, science-based innovation is what will allow us to improve the condition of our communities and the planet. We need to work deliberately on all fronts in ourselves, people, and planet. Because this symposium is about innovation engineering, I end by quoting Sir Eric Ashby, who said, the engineering is the key figure in the material progress of the world. It is his engineering that makes a reality of the potential value of science by translating scientific knowledge into tools, resource, energy, and labor to bring them into the service of men. To make contribution of this kind, the engineer requires the imagination to visualize the needs of society and to appreciate what is possible as well technological but social age understanding to bring his vision to reality. I thank again for the leadership of the University of Illinois Systems. Thank you very much for listening. And I will now introduce Dr. Amayo Llano. Dr. Amayo Llano is the president of the Autonomous University of Querétaro for the 2024 to 2027 term. Prior to this, Dr. Amayo Llano served as the Dean of the School of Chemistry at the same university. She is a highly regarded researcher in the fields of new product development, dairy product science, and starch technology. Dr. Amayo Llano holds a bachelor degrees in chemistry and a master's degree in food science and technology from the Autonomous University of Querétaro, as well as a doctoral degree with specialization in materials from the National Polytechnic Institute. It's an honor to have to have her with us today, and I am delighted to pass the virtual microphone to her. Dr. Amaya, please.
Yes, I have to say that Dr. Amaya can hear us, but she cannot speak right now. There was a small issue in her school, so she will be joining us in a few more minutes later during the program. So thank you so much to our leaders, Dr. President Tim Kalim, Dr. William Lee Aladin, and Dr. Julio Noriega Velasco for your leadership and for your commitment with sustainability, and of course, your passion to educate the new generation of leaders. Thank you to all of you for being here with us today. We appreciate that very much. Now we will start with the program, and it's my pleasure to say a few words about Dr. Ana Barros. She is our keynote speaker today. Is professor and head of civil and environmental engineering. Her primary research interests are in hydrology, hydrometeorology, and environmental physics, with a focus on water cycle studies. Her research relies on remote sensing, intensive field and laboratory experimentation, computational modeling, and environmental informatics. Dr. Barros is the past president of the hydrology section of the American Geophysical Union. She's an editor of the AGU, Advances in PNAS Nexus, and she serves as the American Society of Civil Engineering Industry Leadership Council. She's a fellow in 5 different societies, professional societies, among those the AAAS, and she is a member of IEEE and a member of the National Academy of Engineering. It is a great honor to have her with us today, and I'm delighted to pass the virtual microphone to Dr. Barros. Thank you, Dr. Barros, for making time and being with us today. You are an inspiring leader for all of us.
Thank you so much for your very kind and generous introduction. I was going to say a few words in Spanish, but my Spanish is a Castellano with a really bad accent, so I'm going to spare everyone having to go through that, and I'm going to start my presentation. And say I'm going to actually start on this slide going from right to left. So as you can see on the left, I have a picture of the Latin American Tower in Mexico City. And this tower is really famous because when it was built, was one of the highest or tallest buildings in the world. And Nathan Newmark, who was the head of civil and environmental engineering from the 50s through the 70s, was actually involved in the design of this tower. So this tower is very famous in the civil engineering community and in the earthquake engineering community because it withstood 2 8.0 earthquakes without having any damage. So this is a major remarkable achievement of in civil engineering, and actually Nathan Newmark was later in the century nominated Earthquake Engineer of the Century, and I think in great part because of his involvement with the design of the Latin American Tower. So then moving a little bit to the center, I have, this is just an example, then I'll have a slide about this. We're very proud of this collaboration we have between one of our faculty, Rafael Tinoco, and UNAM. They are working on understanding how sargasso rafts move around and cluster in the Gulf of Mexico. And this research has gone really well. It involves experiment, it will involve modeling in the future. And sargassum is really interesting because it can be used also as a proxy for plastics and other types of contaminants in coastal waters. So we're really excited about this. We know it's going really well. And so that's an example of something that's already going on. And I know there's a big water crisis going on, especially in Mexico City. And there was a very recent article in the New York Times about this, and so I am hoping that we can actually establish some collaborations across with UNAM and with the other universities as well. I actually visited UNAM 10 years ago exactly, It was in the summer of 2014 to give a seminar in atmospheric sciences, and it was really a wonderful visit. So we're looking forward to future collaborations. So I wanted to talk a little bit about our department. So civil and environmental engineering has been around for 170 something years, I believe. And what you see here in these figures are icons of civil engineering in the 21st century that were actually designed or led. The design was led by civil engineers, educated or professors in our department. The Burj Khalifa, the San Francisco Bridge, the Aswan Dam, the Alaska pipeline. And so we're really looking forward to the 21st century and the opportunity to create new icons around the world and in North America of examples of adaptation, of smart infrastructure, and of things that will last and will become representative of our aspirations and improved future for society. So we have about 58 faculty in our department and about 1,400 students. 650 of those students are graduate students. We have about 300 PhD students. And we have a large cohort of alumni all over the world, more than 15,000. We offer a master's program that has a very strong component online. We're ranked #1 masters online because we offer about 40 to 45 courses per semester. So it really lies on the foundation of this very broad range of courses, highly technical courses that are offered every semester. We are offering, recently created new certificates in data science and AI, and specifically directed toward civil engineering and environmental engineering applications. We have the only rail engineering master's program in the country, and this relies on a collaboration with Sweden. And so, this is important. Rail is actually one of the sustainable solutions for transportation, and we have, again, the #1 graduate program. So in terms of our areas of research, we have the very classical areas of research, which are construction engineering and management, construction materials, environmental engineering and science, geotech, structural engineering, transportation, and water resources engineering and science, where I am, anchored. And then we have some interdisciplinary and cross-cutting programs in energy, water, and environment. We have a very strong group of faculty with a very important footprint nationally and internationally in risk and hazard mitigation, sustainable systems, and of course, climate change and adaptation, which is it's not its own independent program, but it underlies a lot of the activities across the programs. So I am going to focus mostly on the water issue just because of the immediate connections, although of course, water is everywhere. And so if you do transportation engineering, you have to worry about water because, either floods or droughts or extreme weather events all impact everything, right? But here, just going through a little bit, we have what's really remarkable about our department is the breadth of not only the research, but also the skills and the tools and the expertise that we have to offer. And they go from laboratory experiments to global climate models, including very detailed models of the boundary layer and specifically of the urban boundary layer, experts in molecular biology, of course, groundwater modeling, remote sensing, and of course, circular nutrient recovery and water technology. I'm going to start with an example that I think is interesting because it sort of shows kind of the thinking out of the box in terms of how to adapt and to extreme events and in a manner that's resilient it takes the best of engineering solutions. So this is the case of Chicago. Chicago has a river that goes through it, and then, of course, at the lake adjacent to it. And one of the big problems in the city that was, of course, has evolved over a couple of centuries and so on, is that it has very large area that has been paved, and so there's a lot of parts of the city have really old water infrastructure and so on. And so when there's a big rain event, and they happen a lot in the Midwest, there's a lot of convective activity going on, then what we have is very rapid production of runoff that is very dirty. So this runoff could not be handled well, and it was going into the river and into the lake and really impacting water quality, which then could not be used as a freshwater resource. So Marcelo Garcia has been involved in developing this solution of a two-way a runoff routing system, where if situations if the situation is normal, we have a system of pipes and networks that take the water that is produced from homes and so on, and brings it into the water treatment plant. And then when there is rain and we have additional runoff, we have actually a complementary system that will take the excess runoff, will bring it into a separate area where it's stored, and then it waits until a later time, at which time it goes through the water treatment plant as well, and then it's released into the system. By doing this, which was really a major work of design and of engineering, we're basically making sure that the waters in the river and in the lake are protected, and you can see here what that system looks like. Another example is, other type of work linked to boundary layer, but in freshwater systems, in rivers, in lakes, but also along the coastal zone, and is Rafael Tinoco. He works with at the interaction of sediment and vegetation in water bodies, and then he complements his work with very sophisticated measuring techniques and also detailed modeling. This is really interesting, and I think it's a great example of how using a very sophisticated sort of technique with the genome sequencing, we can actually unravel a knowledge that was not there before. So this is an example. The picture you see on the left is after a big storm event along the coast of North Carolina, and you see the very dark colors is really dirt runoff. The picture in the middle shows what it looks like. In this region, there are lots and lots and lots of hog farms. So, hogs are a big industrial product in North Carolina. And so the immediate thinking is that when you have these kinds of events, because we have these hog farms and ponds that are used to keep the wastewater from the hog farms, that this pollution would be carried out into the river systems and then into the coast, and then you can see the footprint of this of the pollution plume. It turns out that Helen Nguyen looked at water samples from around all of these river systems and so on, and through genome sequencing, she was able to identify that actually the salmonella that was being blamed on the hog farms, and it's still probably where it comes from, but it's actually already established as part of the natural ecosystem in all of these rivers along the coast. So it has a very different genome footprint than the salmonella that comes from the hog farms directly. So this is an example where land use and natural hazards and so on, all come together to actually change, sort of the natural baseline of a landscape. And so being able to identify and detect when these things are beginning to happen, it's really important, because what this means is that Salmonella enterica is now endemic in some ways in these systems, which brings, the problem to a whole new different level. Alex Tartakovsky, and I wanted to show this because this is the exactly opposite of the sort of work that I was showing for Helen, which is lab-based. In this case, this is highly computational work using physics-informed machine learning to really make it possible to do groundwater modeling at super high resolution in very fast times. This is so important because of hazard controls and groundwater pollution controls, but also in terms of groundwater management and protection. So, I'm thinking there must be somebody out there who's worried about groundwater, and I know that the aquifer that has been used to support water needs in Mexico City is really also overexploited and so on. And so, this seems like an area of potential collaboration. And so with his methods, he can actually, resolve or address problems in ways that had not been possible before. Recently, we formed this Center for Secure Water in the department, where we're trying to look at global problems from the point of view of water quality, of water quantity, of water management, of infrastructure systems. And so we are, because we have the intellectual capacity and intellectual resources, not only in the department, but of course, across the UIUC campus and across the nation through our networks and so on, we're really looking forward to identifying very critical problems related to water sustainability, water quality, and quality of life around the world, and contribute for those solutions. I wanted to, talk a little bit about some of the more, of the type of work that I also do, for example, with hazard prediction. So we have a model that can actually identify the points, the sources of where the origins are of landslides, and so I know that in Mexico this is also a big problem because of the very complex orography. We have been working very hard on developing methods to actually keep track of continental scale water resources and looking at the importance of extreme events. So when we look at extreme events, we tend to think there's always something bad about them, but it turns out that in many regions of the world, actually extreme events, in the case of extreme rainfall, extreme precipitation, heavy snowfall, they're actually the source of fresh water, right? And so they're really important. And how do we balance the importance of being prepared to control them versus actually taking advantage of that importance for water resources. I don't know what's going on with my computer here. It started jumping around. We have a very strong group in the department, including myself, working with AI methods and looking at forecasting systems, hazard systems, operational systems, and of course, integrated digital twins of the Earth system, and we would like to have collaborations with everyone in Mexico. And I just wanted to conclude with this highlight. This is a project that has been funded through I-MMÁS, and it has been a wonderful collaboration. We have our students are involved, our faculty are involved, and I know it's going really well because my faculty member, I asked him for one slide and he sent me 2 long PowerPoint presentations with lots of results. So that means that it's going really, really well. So I'm very excited, and I hope this project will really become, kind of symbolic of this collaboration. Thank you very much.
Thank you so much, Dr. Barros. We have actually 1 or 2 minutes for questions. Questions, you can write them in the Q&A, or I don't know if you can open your microphone and talk, but you can send us your questions here in the Q&A. For now, we don't have questions, but we appreciate so much, Dr. Ana Barros, for your kind remarks and all the very sophisticated and interesting innovation and discovery that you are doing at the University of Illinois. And as I said, for engineers and scientists, female engineers and scientists, you are a role model. Thank you so much.
Thank you very much. Thank you. And
Thank you.
please just drop us an email if anytime. Thank
Okay.
you.
Very good.
Bye.
Thank you so much.
Thank you.
So we'll continue with the next slide, please. We have the pleasure to introduce the next speakers, but the moderator is Dr. Iván Luzardo Ocampo from el Tecnológico de Monterrey in Mexico. Dr. Luzardo will take over from here and the next 2 groups of slides. Thank you, Dr. Luzardo.
Okay, thank you, Dr. De Mejía. I'm not able of turning on my video, but I have the pleasure to introduce Dr. Tomás García Carrera from Tecnológico de Monterrey, and the session will be handled by Dr. Garcia and Dr. Cana a brief minute later. Thank you all.
Good morning, everyone. Thank you for the opportunity to speak at this forum. Thank you, Dr. Elvira de Mejía and Dr. Iván Luzardo for the invitation. My name is Tomás García, and I am professor and researcher at the Department of Bioengineering at Tecnológico de Monterrey, campus Guadalajara, where I lead the Food and Biotech Lab. You are welcome to this lab, to this campus, to Jalisco. My expertise is related to food biotechnology, fermented foods, and health. So today, we are going to speak about some studies. I'm working in the valorization of cheese whey and blueberry byproducts from Jalisco into functional food ingredients. A little bit of my team, our lab, the Food and Biotech Lab, is dedicated to exploring the intersection of sustainability, food, and health. We work on the valorization of our industrial byproducts using fermentation techniques like submerged and solid-state fermentation, and no-thermal technologies such as ultrasound to create functional foods and ingredients. Our research aims to prevent chronic diseases like obesity, especially in the childhood, and mental disorder, while also developing best practice manuals to prevent food loss and waste in the industrial sector here in the States. So our focus is on addressing critical challenges in both environmental sustainability and public health, particularly in the context of the dairy and the beer industries. Our mission is clear: to transform food waste into healthy, nutritious, and accessible foods or ingredients, especially for the most vulnerable population. So there are some key questions we address in our research. For example, what waste material are we going to use and how much of it is produced? What is the environmental impact of this waste? So what types of food products can we create from this waste, and what desirable properties should this product have? And finally, who will benefit from these products and how will we communicate this benefit? Don't forget that, because it's an important issue. So with this context, what are we going to explore today? Firstly, some data about environmental characterization of food loss and waste, and different examples of revalorization of cheese whey and blueberry byproducts. Starting with cheese whey, you have to keep in mind this thing. Check. From 10 kilograms of milk, you obtain 1 kilogram of cheese and 9 kilograms of whey. Considering that the production of cheese in Mexico reaching 2.7 million tons annually, we estimate around 24 billion liters of waste generated each year. And Jalisco has a 20% national dairy quota, so it represents a lot of liter of waste in the state. And don't forget that this waste retains nutrients such as lactose or protein. But what are the real problem here? First one, a large portion of this waste, more or less 50%, is discarded and treated, leading to severe environmental degradation, especially in regions like the Santiago River. You can see here the picture, all the pollution in this river. And the second one, the challenge is particularly pronounced among small and family-owned businesses, which often lack the resources for proper waste treatment. So we have conducted an extensive environmental characterization to understand the scale and impact of this waste disposal. For example, mapping the production, interviews with producer, physicochemical analysis of collected samples from more than 20 cities, estimation of greenhouse gases, and evaluation of different solution or scenarios. So here you have a heat map with critical areas with the highest concentration of waste production. You can see in brown and brown-red color. Obviously, all areas should be considered, but these particular areas are the interest to address a solution from these scenarios: field irrigation, aerobic oxidation, anaerobic digestion, animal consumption, and human consumption, of course. In response, we have been working on creating biotic foods and ingredients for this way. We focus on developing probiotic and postbiotic formulation through a fermentation process that not only use whey, but also leave no residue. This formulation contain, in the case of probiotic formulation, live microorganisms, and in the case of postbiotic formulation, inactivating microorganisms by different thermal and non-thermal technology, and both contain this formulation confers significant health benefits, and we're working on validating this impact on gut microbiota from children with obesity, and of course we also checking antioxidant and anti-inflammatory property with cellular model. On the other hand, in the berry industry, we have detected substantial losses due to insect and fungal pest condition defects, like overripe fruit, size defect, lack of bloom, and of course, for harvest processing issues. You can see here in the scale, mostly related to transportation and storage. In Jalisco, where blueberries are a significant crop, this waste can account for up to 10% of the total production, even 15, 20%, depending on the company, depending on the season, depending on the blueberry variety. Rather than letting these byproducts go to waste, we see an opportunity to create functional ingredients with antioxidant and prebiotic properties. We designed a complete revalorization scheme from no premium blueberry. You know, the premium and the good blueberries go to the market. And from this no premium blueberry, we obtain juice and bagasse. Bagasse is a mix of rest of pulp, seeds, and peels. And from juice, we obtain a fermented smoothie and natural syrup, which was added to a petit Swiss cheese model. From bagasse, we firstly removed the water to obtain an ingredient that was used in a frozen dairy snack. And from this bagasse, we perform a solid state fermentation to obtain antioxidant extract And with the waste, we generated a dry ingredient to be incorporated in a bread. Again, zero waste approach. So some of this work has been published in different journals, and now we are working on validating this functional foods through intestinal digestion, colonic fermentation, cellular assays, etc. Recently, we published a comparison of different berry byproducts, and especially the blueberry one is rich in fiber and phenolic compounds and shows excellent antimicrobial and prebiotic properties. This can make it effective at preventing chronic diseases, useful, of course, for food and pharmaceutical industries. Finally, we also explored the potential of combining whey and blueberry byproducts to create new formulations to address mental health. These psychobiotic and symbiotic formulations contain a mix of prebiotics and probiotics, and they could have a significant impact on the prevention and management of mental health disorders, such as depression, anxiety, and even cognitive decline. So we are validating that using a murine model. As a conclusion, this research is about more than just creating new food products. It's about driving sustainability in the food industry by turning waste into value. By leveraging biotic ingredients and advanced fermentation techniques, we are creating functional foods that not only contribute to better health outcomes, but also help protect our environment. I believe that this research can serve as a model for collaboration between academic institutions and industries across borders between Mexico and Illinois, like today. Together, we can drive meaningful impacts in both our environment and our communities. So thank you very much for your attention. Here you have my email, social media networks. Yeah, thank you very much all for my research funding from Tecnológico de Monterrey, Jalisco government, even the company Bloom Fund. Thank you for my crew. And yeah, I will be very happy to answer your question. Keep going. Keep enjoying the forum. Thank you.
Thank you, Dr. Garcia Cayuela, for the presentation. We are collecting all the questions at the end of this section, so people will be able to share and ask in the QA tool at the end of all this section. So now we are moving on with Madhu Khanna. She is our keynote speaker of today. She is the Alvin A. Bounds Family Chair and Director of the Institute for Sustainability, Energy, and Environment. She's also an AC Distinguished Professor in Environmental Economics, the Director of the Center for Economic Sustainability of the Department of Agricultural and Consumer Economics of the University of Illinois at Urbana-Champaign. Thank you, Dr. Khanna, for being here, and we will start with you. Thank you.
Thank you very much. I will share my slides. So thank you for this invitation to be here and share some of my work. I'll just quickly explain what I do. I'm an environmental economist by training and also the director of the Institute for Sustainability, Energy, and Environment. My research focuses on looking at the economic incentives for adopting technologies that have the potential to be environmentally beneficial, but often don't get adopted for various reasons. And I look at how we can incentivize their adoption through various types of agro-environmental policies. I'm also interested in studying why corporations, many corporations are making efforts to be socially responsible, and I examine their effectiveness in doing so and how we can induce more corporations to similarly be more environmentally responsible. And then a lot of my recent work is also focusing on looking at the land use and the environmental impacts of renewable energy technologies, specifically looking at bioenergy and solar energy in the context of the US. Very quickly, I also want to give you a brief idea about the Institute for Sustainability, Energy, and Environment on our campus. The Institute is intending to foster interdisciplinary research. We bring together faculty and other researchers from across campus to collaborate and study complex problems related to increasing the sustainability of our planet through various technological, economic, policy solutions. We also have programs to encourage more interdisciplinary education and to make our own campus sustainable. Our institute has research groups that are working in 5 different areas related to climate change, renewable energy, sustainable agriculture, sustainable infrastructure, and then water and land stewardship. And one of our big projects is looking at how we can develop advanced bioenergy and bioproducts from perennial energy crops. So this is a very large interdisciplinary project, and I'm happy to share more information on that later if there's interest. We're also looking at how we can do agrivoltaics, which is to do solar energy generation and crop production on the same land so that we can use our land more efficiently. And quite a bit of research happening on the use of digital technologies and AI for making our farming much more sustainable. So here are some of the examples where our researchers have developed robots and drones that can do farming operations and in a much more sustainable way. And so my talk today is going to pick up on that theme and elaborate on that. And really one of the goal of this research and really much of the research that happens in the Institute is to see how we can solve this grand challenge of making our agriculture and food production and so on more sustainable. And the goal is to increase crop productivity, but at the same time reduce the environmental harm that is caused by agriculture. And at the same time, we have to mitigate and adapt to the changing climate. So some of the challenges we face in doing that, at least here in the US, is that there's a very high cost of labor. And so it's extremely difficult to do sustainable practices that are labor intensive. There's also growing resistance to herbicides, and we need to reduce the use of chemicals. But there are very few alternatives to reducing the use of chemicals while continuing to have yield and reduce the damage from herbicides and pests. And our current tillage practices are very intensive. And as a result, we have a declining soil health problem, which is threatening crop productivity, even in the Midwest. And globally, we know that across the world, there's a tendency for farmers to over-apply nitrogen. And the nitrogen use efficiency is relatively low. It's only about 40 to 60% across the world. And so the rest of the nitrogen that is not being used by the plant is essentially part of the runoff that then causes degradation of water quality and drinking water problems and so on. So we want to increase the efficiency with which we are applying nitrogen. We also want to deal with the problem of soil degradation that is caused because of excessive tillage associated with agriculture is one of the reasons for that. And so there's a need to build up soil health. And so, some of the research that we're doing here at the university and through our institute is looking at, what is the future for sustainable farming and how we can use digital and artificial intelligence technologies in order to enable that. And so we're working on a variety of different technologies, but there are really 3 main features of these technologies. The first is that they can gather very high resolution data on plants and the growing conditions in the field, and they can enable the management of the field at with much more precision, so that the right amount of fertilizer and chemicals are applied at the right place and the right time, instead of just uniformly applying fertilizer and other chemicals in a way that there's over application in some areas and under application in others. The second feature is the growing use of machine learning as a way to use this high resolution data to be able to make predictions and recommendations for farmers so they can progressively get more accurate in the way that they're managing their field. And then lastly, there is the increasing use of autonomous equipment and robotics that can make these site-specific interventions on the field during the growing season without the need for as much labor. So just as one example, we're developing this weeding robot that can go in between the canopy of the corn plants, the standing crop, and mechanically remove weeds without applying herbicides. And these robots have got high weeding efficiency, they reduce the need for labor and of course, reduce weed resistance. Another approach is to build soil health, and that is through planting cover crops. And so at least in the Midwest, we have many months, about 6 months in the year or so, that are bare soil in the winter where nothing is growing, but the soil is bare and subject to a lot of wind and water erosion. And so planting winter cover crops can increase soil health, soil carbon sequestration, and long-term productivity. But planting is costly and labor intensive, and there's no revenue from it. So, currently very few farmers, less than 10% of the farmers are practicing cover cropping. And most of this is done in the month of November when it's already getting cold and after harvest. So our researchers here have developed these robots that can essentially plant these cover crops even with the standing crop, in July and August when the weather is warmer. These robots are small robots. They can go underneath the corn plants and spread the seed. And so as you can see on the graph on the pictures on the right, the cover crop establishes a lot better, and it's much more effective as a way to plant cover crops and really cover the soil, and to be able to do that without as much labor. And in the long run, we hope that the cost of this will be much lower than the cost of current approaches. This is a similar technology that is being used to plant cover crop seeds aerially, again over large areas with without the need for as much labor. So, artificial intelligence technologies, really have the potential to provide a lot of value. Right now, we are at very early stages. We are using, doing some precision farming. We're doing robotics and sensing. But in the long run, we have the capability to really move into things like digital twins, where we can map and model the farm at a very, spatially explicit, fine resolution, and be able to analyze on the, computationally how different interventions can work without having to make expensive experiments on the field. So there's, this is only going to get better in the future and provide a lot of value. A lot of my research looks at what types of farmers are likely to adopt, what are some of the barriers to adoption, how we can mitigate those barriers, and what kind of policies and market conditions need to be developed in order to induce adoption. And also, what are some of the risks associated with digital technologies, including what are the equity impacts, how is it going to impact the small and the marginal farmers relative to the large farmers, risks of cyber attacks, and so on. And, how do we mitigate those risks so that these technologies can be used for the social benefit? So I'm going to stop with that. Here is some of the information to follow up on, and I'm happy to answer questions after this is done. So thank you very much.
Thank you, Dr. Kana, for the presentation. So now I'm presenting Anne-Marie Hanson. Dr. Hanson is the Interim Associate Dean of the College of Health, Science and Technology of the University of Illinois at Springfield. We are very pleased for having you here, and thank you for your presentation.
Hello, everyone. Took me a moment there, but thank you all so much. Muchas gracias por tenerme aquí con todos ustedes. Me da muchísimo gusto estar presentando con ese grupo fenomenal de profesores y líderes en ese tema de sustentabilidad. I would like to share some of my work today from my work in Mexico and internationally. By training, I am a geographer and a political ecologist, and I'm currently working as the interim associate dean for the College of Health, Science, and Technology. I have a lot of connections in Mexico through my family, as well as from several years I spent living there in the Ciudad de Mexico and in Mérida for school and for work purposes. So I would like to share some of the collaborative work that I have been involved with. Almost all of my research is applied policy work, and virtually everything I have done has been collaborative and interdisciplinary by necessity, with a recent focus on convergent science. I primarily explore issues of gender and environmental responsibility, as well as issues of environmental justice, and examining how these intersect with technical issues and managerial aspects of waste management, plastic pollution, and coastal ecosystem management at various scales. So today I'll be sharing some insights from my work as a gender specialist with my international colleagues, particularly through my involvement with the UN Environment Program and the Gender Water Alliance. Here I am featured with my co-author on the recent UN report on gender mainstreaming in coastal and marine ecosystem management. My co-author, Anamika Amani, and Patricia Quignolo is not in the photo, but very much part of this report. A main objective of my work and my collaborative work, our work, I should say, is to introduce practical gender mainstreaming guidance for practitioners and policymakers. Our recent reports and webinars focus on bridging the gap between gender experts and coastal marine researchers, encouraging the integration of gender analysis into their work. So in our most recent report, we compiled 10 diverse case studies from coastal regions around the world, covering a wide range of themes in coastal and marine ecosystem management. Each of our case studies in this report also highlighted 10 gender principles that can be applied as strategies for promoting socially just and sustainable development in coastal areas facing multiple hazards and challenges in their work. My work in this area has also strengthened my focus now in my position as Associate Dean for promoting and leveraging diversity in science for nature-based solutions and sustainable solutions. This Venn diagram, I just wanted to share. It is included in much of our work, but it highlights the overlapping themes between coastal management and gender analysis. Coastal management for themes include things such as ecological restoration, resource management, employment, livelihoods, resilience to climate crisis, and waste management. Gender analysis intersects with these by focusing on many themes related to the access to resources, participation in decision-making, and recognition of multiple stakeholder and voices and contributions. So the need for more collaborative work in this area is driven by the frequent and multifaceted hazards that coastal communities and ecosystems face. So for example, coastal areas are the first hit by cyclones and storm surges and are often the last or final collection points for land-based pollution and plastic waste. Remote coastal inhabitants are also often the hardest to reach with emergency relief efforts, oftentimes making marginalized communities even further marginalized. Coastal vulnerability in general refers to the susceptibility of coastal areas to natural and human-made hazards. Increasingly, these areas face multiple interconnected hazards that increase this vulnerability, including things like more frequent extreme weather events, increased urbanization in coastal areas, sometimes formal and sometimes informal, as well as different types of pollution, both coming from ocean-based and land-based sources. And all of these also link to sanitation problems and issues with water that can increase water and vector-borne diseases throughout communities. Also, all of these things combined add to mental health crises linked to stress, anxiety, depression, and trauma. So when COVID happened, so it just so happened when we were working on this research that it was the years of 2020 to 2022. And so there was just, we all know, so many impacts from the pandemic. Many coastal communities were already vulnerable to these multiple hazards before COVID, and then the pandemic exacerbated these challenges. So some of the most prominent impacts is that there were severe economic impacts when there was abrupt employment in industries such as fishing, aquaculture, and tourism. And so women and other groups depending on these industries were disproportionately affected, and many losing their jobs almost overnight. Examples of this can include stranded migrant fishers, the closure of fish processing factories and tourist operations, and the loss of markets for both women and men in the fishing industry. In some areas, overharvesting and environmental degradation during the pandemic continue to have longer-term impacts. All crises have a disproportionate impact on women. Crises tend to worsen existing gender disparities and discrimination, leading to increased violence across health, economic, and social spheres. Women and children are actually 14 times more likely to die in natural disasters than are men. The COVID pandemic intensified issues, mental health issues such as addiction, also things such as gender-based violence and mental health challenges in coastal regions. So we saw an escalation in gender-based violence, not just in coastal regions, but around the world, but in particular for these communities already facing other types of hazards. We had an increase in intimate partner violence, in public and online harassment, as well as increases in child marriages, trafficking, and femicides. In addition, there are many clear political and aid disparities, such as gender-based or gender-blind aid distribution policies, in some cases, gender-based discrimination. Oftentimes, in many areas around the world, we found relief is tied to political support, often excluding women. And as I already mentioned, highly gender-blind policies for pandemic recovery. So all of these points highlighted health and recovery gaps when faced with multi-hazards, such as the unequal access to health resources and recovery and aid, the under-prioritization of women-specific needs, such as reproductive health care, and the inadequate safety and child care support during recovery efforts. So importantly, we have found that despite varied responses to COVID-19, many coastal communities have demonstrated resilience through strong community solidarity and environmental recovery efforts. Also, while it is now and during the pandemic became more widely recognized around the world that hazards impact men and women differently, only 9% of global pandemic recovery policies were gender sensitive or gender responsive. Virtually all pandemic recovery policies were gender blind, as are the majority of hazard responses. Although, and a key term for long-term sustainability is to move towards, at a minimum, gender sensitive or gender responsive policies to alleviate any type of long-term effects. So some of our post-pandemic work in this area underscores several additional points. There's a clear need for more gender-sensitive and gender-responsive protocols to enhance disaster preparedness and response. Second, the impact of gender-inclusive policies is huge. Coastal areas, the few coastal areas with gender-inclusive policies coped far better and demonstrated greater resilience when facing multiple hazards. Also, third, local networks and women-led groups tend to be crucial in supporting vulnerable populations. In regions without gender-sensitive protocols, successful relief efforts are often driven by women and youth-led initiatives. And then lastly, what we have found is increasingly important is digital communications and social media. In following some of the hurricanes and other natural disasters that coincided with COVID, social media played a vital role in information sharing where this was accessible to users. Simple tools like WhatsApp and PayPal oftentimes enabled small businesses to thrive, or at least to manage and to survive when larger networks failed or were shut down. So some of the examples, I just wanted to share with you two case studies that were the few examples from Mexico that we have in our larger global efforts. The first one was from Mexico. So we had a partner, a case study with the Doctora Nelly de Barajas, who is the director of CEDO in Sonora, Mexico. And she led a successful, has been working for many years on participatory coastal marine spatial planning projects. And this involves huge numbers of stakeholders, a large amount of territory, and many people with conflicting values and interests. But what she found is this project highlighted and the importance of leveraging the strengths, knowledge, and skills of both women and men and in order to create long-term sustainable planning efforts that include so many different multiple stakeholders. Also, she found that strong female leadership was especially crucial in encouraging broader participation in these efforts, and particularly within smaller communities that are next to very large industries or very large, going up against I guess I would say, feeling as though they have less of a voice as people from larger communities or some of the industry interests. Another example from my own research is from coastal Yucatan, where I collaborated with women's groups Las Costeras and Chencolob. And Chencolob means only women in Yucatec Maya. And they have been working for about 2 decades on tackling the combined challenges of plastic pollution, waste management, and the influx of sargasso. So I was very excited earlier in the presentation to learn all the exciting things working with the engineering with the sargasso. I am not an engineer, but working with the people who are dealing with this in their daily lives. And so as Dr. Barros mentioned earlier in her presentation about the sargasso, the term the brown tide is often as what we refer to the large amounts of sargassum that form in the Sargasso Sea and later wash ashore, accumulating in coastal areas all around Yucatan and the Gulf of Mexico. So it is a floating brown algae that can create these dense mats, as you can see here on the ocean surface. It's a natural part of the ecosystems, but in the last 10 or years, it just has exploded. The number has increased exponentially due to a combination of pollution and other factors in the ocean. And so part of the work that I was doing when I was working there, we were initially focused on waste management and plastic pollution. But then as the influx of seaweed came along, we also see the increased amount of seaweed bringing in the plastic waste. And so it is not just the brown tide, but it's also mixed in with all different waste products. And so this map is older, but it is from a UN report where, right, showing the concentration of microplastics in the Sargasso Sea. And just giving an example of where all of this comes and how it ends up being on the beaches in Mexico and throughout the Southeast United States. So the work where I did in this area was women in very small towns in northern Yucatan have been networking for almost, I said, for 2 decades to address these issues, combined issues of plastic pollution, marine debris, and the Sargasso. So in areas, for example, lacking waste management in small residential areas that also tend to receive large influxes of seasonal tourists, women have networked to collect household recycling and become part of larger state integrated waste management programs. There are also women groups that have been some of the first groups to pioneer the collection of washed up Sargasso, turning it into compost for local farmers and community gardens. And as some of you showed, this is not related to my work. I just found some images of examples of small businesses that have found ways to use the Sargasso and turn it into things like artisanal soaps, notebooks, bricks, building bricks for construction, and even things like shoes. So I wanted to share this last one, even though I have nothing to do with all these small businesses, but it also piqued my interest in thinking of the circular economy. And I know many of you here will also be speaking on that topic. And so I am eager to continue working on those topics I already mentioned, but the experience also led me to work with colleagues across the UI system on a larger sustainability research networks focused on circular innovations in Illinois. And so we have a group of not just UI system, but larger network working on this project we are calling Circular. I know other units across the UI system are similarly tackling issues related to circular economies. And also in the College of Health Science and Technology at UIS, we are really working on finding innovative and interdisciplinary science training paths that can connect our students to the rest of the UI system, as well as applied research and clinical opportunities in Mexico and elsewhere. So I would be very excited as well to, make those connections in those areas. And I am very much so. That is all I have to share with you today, just a brief introduction, but I really look forward to exploring further collaborations through this network. And I appreciate the opportunity to share and be part of this wonderful event. Mucho gusto a todos y muchas gracias.
Thank you, Dr. Hanson, for your presentation. I believe introducing the principle is essential in research, so thank you for your perspective and presentation. So now I'm introducing Dr. Rocio de la Torre Sanchez. She is Head of Technology Transfer at the Material Research Institute and a Real Academy of Engineering Fellow of the Universidad Nacional Autónoma de México. Thank you for being here, and we will start with your presentation.
Thank you. Gracias por la invitación. Good morning, everyone. Thanks for inviting me to speak today. It's an honor to be here and to share the work we are doing to advance sustainability through innovation. My name is Rocio de la Torre, and I am the head of the Technology Transfer Office at the Materials Research Institute. To give you a bit of my background, I hold a bachelor's degree in chemical engineering, a master's, and a PhD on biotechnology and bioengineering, focusing on soil remediation, modeling, and simulation. At the beginning of my career or academic journey, my education was focused on building a strong scientific profile. Therefore, my work was centered around scientific objectives. However, as I transitioned into the role of Head of Technology Transfer Office, I realized that this position demanded a broader set of skills, I needed to specialize in areas beyond pure science, such as business management, intellectual property, and scientific communication, to effectively connect our research with industry and society. And more recently, recognizing the critical importance of sustainability, I pursued a master's degree in sustainability and circular economy. This step was essential to align our innovations with the growing environmental demands and to ensure that our work contributes not only to scientific advancement, but also to a sustainable and circular economy. At the same time, due to the increasing importance of structural innovation, I also became an innovation management system practitioner under ISO 56002 in order to guide our processes to foster effective and sustainable innovation. Well, in this slide, I would like to represent the global impact and responsibility of the work we do at the Institute. Just as these hands hold the world, our Institute is moving to create more solutions that address global challenges, with a particular focus on sustainability and equity. My role at the Institute often makes me feel like a translator or bridge connecting the academic world with the industry, as a knowledge broker or a problem solver. I facilitate the transfer of knowledge and innovation from the research lab to real-world applications. We consider that it is crucial for ensuring that our scientific advancements don't remain confined with academia, but are translated into tangible benefits for society. The importance of building strong links between academia and industry cannot be overstated. These collaborations are essential not only for advancing technological innovation, but also for ensuring that these advancements are sustainable and contribute positively to the world. By fostering these connections, we aim to ensure that our research at the Institute supports societal needs, addresses environmental challenges, and finally leads to a better, more sustainable future for all. As the head of the Technology Transfer Office, I contribute with the mission of the Institute in order to conduct cutting-edge research in materials science, fostering the development of innovative technologies and applications, and contributing to the advancement of knowledge, training highly qualified human resources, and promoting collaboration with industry and other academic institutions. Our institute is organized into several research departments, each specializing in different aspects of materials science. These include rheology and mechanics of materials, low-dimensional materials, condensed matter, and cryogenics, metallic and ceramic materials, and polymers. We also have a multidisciplinary approach that integrates chemistry, physics, biology, and engineering to tackle complex challenges in materials research. Technology transfer is one of our objectives at the Institute. Achieving this is crucial for ensuring that our work not only contributes to academic knowledge, but also has a tangible and positive impact on industry and society. Moving forward, we are committed to strengthening our efforts in this area to bridge the gap between research and real-world applications. Well, in the next slide, I would like to show you how it was supposed to be the path or our journey. Researching on innovation requires navigating through several critical stages. As this diagram, the journey from a basic idea to a tangible innovation involves a series of steps, including basic science, research collaboration, peer review, applied science, IP management, and finally, technology transfer. However, one of these significant challenges we often face is even reaching the stage of applied science. Identifying or achieving this phase is crucial because it's where theoretical concepts start to take shape in practical terms. Without at least reaching this stage, it becomes incredibly difficult to move forward toward genuine innovation. In many cases, the transition from basic science to applied science requires not only rigorous research, but also collaboration, adequate funding, and a clear pathway to application. This is where our efforts are currently focused, ensuring that we can push our ideas further along this continuum so that they have a real change and impact in the society. Therefore, when we talk about innovation, it's a topic that has been extensively explored and discussed. As you can see from the vast number of books on the subject, these resources offer diverse perspectives on how to drive innovation in different contexts. The common thread among these works is the emphasis on understanding that innovation is not just about creating something new. It's about creating something that adds value to society. As we navigate the challenges of our rapidly changing world, these insights guide us in our efforts to push the boundaries of what is possible. Innovation is not confined to research labs or tech companies. It's happening all around us in every aspect of our life, from healthcare to education, from everyday objects to cutting-edge technologies. Innovation is the driving force that improves our quality of life. It's the process of taking an idea and turning it into something practical, something that meets a real need. At the Materials Research Institute, we strive to embed this mindset of innovation into everything we do, ensuring that our work not only advances science, but also creates tangible benefits for society. So, what exactly is innovation? Innovation is the successful creation and delivery, and this is very important, the delivery of a new or improved product or service to society. It is the process that transforms an idea into value for the customer, generating sustainable benefits for the company and the community. These definitions underscores the importance of not just having ideas, but being able to implement them effectively in a way that is economically viable and socially responsible. The journey from idea to an innovation is not always straightforward. It begins with identifying a need, which sparks an idea. However, turning that idea into an invention is just one step in the process. The real challenge lies in breaking down the barriers, whether they be technological, financial, or organizational, that stand between invention and innovation. At our institute, we focus on breaking these walls, ensuring that our inventions become successful, that have meaningful impact on the world. And the SDGs provide a roadmap for addressing the most pressing challenges our world faces today. This goal emphasizes the importance of innovation that is not only groundbreaking, but also sustainable and inclusive, ensuring that no one is left behind. At the Institute, with our projects, have historically focused on advancing materials science, but we recognize the increasing importance of aligning our work with these global goals. Currently, our projects are not fully aligned with the SDGs, but this is something we are actively working to change. From my position in the Technology Transfer Office, we are strongly encouraging and motivating our researchers to consider how their work can contribute to these broader global objectives. We believe that by aligning our research with the SDGs, we can amplify the impact of our innovations, ensuring they contribute not only to scientific advancement, but also to societal and environmental sustainability. In line with our efforts to align with the SDGs, we also see the potential of the ISO Innovation Management System as a framework that we could further support this transition. We recognize its value in providing a structured approach to managing innovation, ensuring it aligns with strategic goals and societal needs. ISO 56002 emphasizes leadership, planning, and continuous improvement, all crucial elements for driving innovation that is both impactful and sustainable. By incorporating its principles, we can better structure our innovation processes, ensuring they contribute to the SDGs and generate real value for society. As we move forward, aligning our projects with the SDGs and exploring the adoption of ISO are key priorities. This dual approach will help us ensure that our innovations are not only scientifically advanced, but also socially and environmentally responsible, contributing to a better future for all. It is important to recognize that innovation doesn't happen in isolation. It requires the coordinated efforts of multiple sectors. I mean society, government, academia, and industry, all working together towards a common goal. This is where the 4 years model of enabling responsible innovations comes into play. In this model, each sector plays a critical role. Society gets involved and supports resolutions. Government understands citizen needs and designs smart policies. Academia generates and communicates knowledge with integrity, and industry creates value while managing risk responsibly. With these gears work together in harmony, they drive responsible innovation, a process that not only advances technology and science, but also ensures that these advancements build the future we want, aligned with societal values and sustainability goals. At the Institute, our goal is to foster this kind of collaboration. In line with this approach, the Technology Transfer Office has actively participated in various national and international events aimed at strengthening these collaborative efforts. From programs like the NSF Innovation Corps and Climate Launchpad to initiatives by the Royal Academy of Engineering, we have been involved in platforms that promote the scaling up of innovation, the transformation of scientific ideas into startups, and the development of sustainable technologies. These events have provided invaluable opportunities to connect with stakeholders across the globe, share knowledge, and explore new alternatives for collaboration. They also help us ensure that the innovations coming out of our institute are aligned with the principles of responsible innovation, contributing to the SDGs and social well-being. While we recognize that our current projects at the Institute are not fully aligned with sustainability, we have identified several initiatives that hold significant potential in this regard. These projects include the following. First, sustainable construction materials, where this project will focus on developing construction materials that decompress, recycle, or renewable resources. The potential impacts includes reducing the environmental footprint and increasing accessibility for low-income in communities, which aligns closely with goals such as responsible consumption and production and sustainable cities and communities. Another project is the biodegradable polymers for the medical applications. This initiative explores the use of biodegradable polymers in medical applications like drug delivery systems and surgical implants by minimizing medical waste and also reducing environmental contamination. This project can support goals related to good health and well-being, as well as responsible consumption and production. The next project might be energy-efficient materials for renewable energy. The development of materials that enhance the efficiency of energy technologies, such as solar cells and batteries, could significantly contribute to the goal of affordable and clean energy, while also supporting climate action by reducing reliance on fossil fuels. The next project might be advanced filtration materials for clean water. In this project, will be focused on creating novel filtration materials to remove contaminants from water and more efficiently, and it aligns with the goal of clean water and sanitation. And finally, a sustainable material for packaging for food preservation by developing biodegradable and recyclable packaging materials that extend the shelf life of food products. This project addresses the goal of responsible consumption and production. So, in conclusion, the Materials Research Institute plays a crucial role in advancing sustainable innovation. Through our cutting-edge research, we are developing high-performance materials that might contribute significantly to a more sustainable future. Our work is not just about innovation for the sake of advancement, but is moving about innovation with a purpose. Innovation that leads to a real-world benefits for society and the environment. We see ourselves as a catalyst for change, and the Institute is fully committed to collaborate with industry and other stakeholders to implement these sustainable practices. Well, before we wrap up, I want to thank each of you for your attention and engagement today. The work we do at the Materials Research Institute is deeply connected to the broader goal of creating this sustainable future, and I invite you all to consider how we can collaborate and leverage our collective expertise to make these innovations a reality. I am really sure that together we can build a future that is not only innovative, but also responsible and sustainable. Thank you once again for your time. I look forward to any questions you may have and to the possibility of working together to advance these important initiatives. Thank you.
Thank you, Dr. De La Torre, for your presentation. So now we are going to have the question and answer section. So there are some questions that have been written in the utility. I will highlight one from Marco Antonio Rubio Ramos, which is, I believe, to Dr. De La Torre. It
Yes.
says, according to your experience, besides the required knowledge, there is a kind of barrier to the ability to write and communicate in the English language in order to collaborate more actively.
Well, I don't think that the language is a barrier. I mean, I have been in many different meetings, even in German and in Dutch, and I think the bigger barrier is not the knowledge, is the focus on the work. Sometimes we are just talking about the scientific, I mean, the paper or the, well, this kind of work that we are all involved, but the barrier that we have to break is that all the scientific work is focused on society, to develop projects that really have a great value on that, are really impact. Sometimes we're producing something and we don't know if it's going to be useful, and it just become an article or a paper. So I think that the barrier is not the language. I think it's the way of thinking. I think it's the biggest barrier that we have to break down.
Thank you. And according to that, do you believe that there is still that barrier of the global south compared to the global north? So perhaps the research that is conducted in the so-called middle income and low income countries, perhaps it doesn't have the visibility it should have, because perhaps a science could be dominated by certain research group. What do you think about it?
I think that more than being dominated by a specific group, I think that sometimes it's related with the evaluation of our researchers. So you have to be like in a run in order to get some grades or something like that. So I don't think it's about the income. It's about the way that we are focusing our research. And in that case, I think that our government or the policies will move into more support for this kind of technologies. It's not just about the country, it's about the support that we have.
Okay, Dr. De La Torre, thank you. So as we don't have more questions in the Q&A section, I had one question for Dr. Cana. So I would like to ask you how farming and agricultural producers other than the USA or countries that you suppose they have like the economic support for this technology could access to them? Are there like grant or international funding for this advancement? Okay. Dr. Cana, are you in the Zoom session? Okay, so if any one of you have additional questions, please let us know. So we'll know. Okay. So, Dr. Hanson, are you able to? Okay, let me.
I wonder if Dr. Cana has her phone open.
Yes.
Okay. Would you like I repeat the question, Dr. Cana?
Yeah. Could you repeat
Okay,
the question?
sorry. Yeah, okay. So you have spoken about some technology that can be introduced into agriculture, but are these technologies like expensive? Perhaps are there like grant or funding from low income or middle income countries so they can access to these technologies in agriculture?
Yeah, so that's a really good question. And while some of these technologies are currently more expensive, but the goal is that the costs are going to decrease with more research. And also, many of these technologies are much smaller. As you see, some of these robots are much smaller in size, and they're not the large equipment that farmers currently have to adopt. So there's some, ways in which these are quite suitable even for smaller farmers to adopt, but certainly their costs have to come down a lot, and a lot of technical expertise will be needed in order to operate them. So that is a goal of research, is to make sure how can we have, how can we make this beneficial for all farmers to benefit from.
Okay, thank you for your answer. And I also have a question to Dr. Anne-Marie Hanson. So overall, what you believe are your recommendations to introduce general principles in the academia so we can move them more effectively into research?
The first would be to, even in engineering fields, include someone with with gender analysis expertise as a consultant or as a, that can come. There are many effective people even within the UI system, I am sure, probably in Mexico as well, that have this training. Oftentimes it is more applied, I would say. The other thing would be like there are many toolkits out there already for practitioners in sustainable development fields and practical ways and simple ways to do this, such as just ensuring the data that you collect is gender disaggregated, things of ensuring that the science that you are building and the technologies you are building are able to actually address the concerns of the people in the area where and ensuring the voices of diverse stakeholders from the area are there. And in some ways, in some cases, we have found that where new technology can be introduced, but not all people will have access to it or will not all have the training to use the new technologies. And so, there is a number of concerns, but I would say within there are little steps that can be taken to ensure that those things don't happen, right? And so I would say, yes, if anyone would like, gender toolkits, there are many out there, but I will be happy to share some resources in that area. As I mentioned, I think some of it just starts by making sure they're aware of the impact of this on long-term sustainability planning and technologies. I hope that answered your question. Thank you so much.
Yeah, thank you so much. Okay, so now it's 10:50 in Central Mexico time. So now we are going to have a small 10-minute break. So we will be back in 10 minutes. Thank you all for being here, and we'll get back to you.
Thank you so much, Dr. Luzardo Ocampo, Tech of Monterrey. We will start sharing the bios of our speakers, and please, participants, feel free to continue asking questions in the Q&A, and the speakers will answer those questions. Thank you so much. We'll be back in 10 minutes. Thank you. Muy buenas tardes, bienvenidos de regreso a nuestro Symposium, Innovación en Ingeniería para Sostenibilidad. Welcome back, our dear colleagues and friends. The break is over, and I want to thank our previous speakers for their outstanding presentations. So I want to thank Dr. Tomás García Cayuela, Dr. Madhu Khanna. I want to thank Dean Anne-Marie Hanson and Dr. Rocío de la Torre Sánchez. Thank you so much for outstanding presentations. Now we have the next set of presentations, also outstanding speakers, and I want you to meet the moderator for this section is Dr. Cristian Appendini from National University of Mexico. Dr. Cristian Appendini, thank you for your help and support to I-MMÁS and the initiative between UNAM and the University of Illinois system. Thank you.
Thank you, Elvira. Hola, buenas tardes a todos. So now it's my turn to present the following speakers. And the first speaker is Dr. Carla Graciela Sedano Villavicencio. She works at the Renewable Energies Institute of UNAM in Morelos, right? In Temisco, I guess. And well, she is going to present her work related to sustainable energy transitions, social justice, and inclusiveness. So with no further ado, I leave you to your presentation. Thanks.
Thank you very much. I asked Elvira if I had to share my.
Yes, please.
Yes? Okay.
Yes.
So yes, I think that something happened and we were not connecting clearly. So let me see. I'm sorry. How can I do this? No? Listo. Let me see. So thanks, and I'm really excited about sharing with you what we're doing at Institute for Renewable Energy. It's been an honor to listen to all the presentations, and here we go. So first of all, as you've seen what we're working on, that's a little bit. My background is engineering, and that is how I would like to start. So mainly engineering, I want to express that it is a social process. That's how we are understanding our role in society. Being that said, I have a quote here that insists that engineering has to have a focus on improving human life. And we have to create responses to social needs in order to be like this missing link in, let's say, development of societies. So with this vision is that we have been working, and also I wanted to put there the context of what sustainability means for us. I am glad to see that this is a shared, let's say, a shared view from all of us, that sustainability goes beyond environment, goes beyond economy, and also beyond social. We have in our countries, especially Global South in general, to put a focus on the institutional component of sustainability, on the regulations, the culture, the context that our countries live for example, in our communities in Mexico and in the States. So with this vision, and also a vision not only focusing on the future, but in the present. We believe at our laboratory that we have to close present gaps in terms of sustainability and start action now and work as soon as possible with these pressing issues. This is let's say, a small graph that Irina has showed us in the past about the importance of energy, of sustainable and clean energy for all the persons, and how it has an impact on economics, on social, and on environmental issues, and how it meets the cultural and institutional aspects of promoting networking, like here, and also on having these collaborations with different sectors and instances. And this is in response to those pressing challenges that Dr. William Lee was talking about. I do think that we need to understand these cultural and these important regulatory spaces that we have in our countries. And very briefly, innovation for our team in the Innovation and Future Labs at UNAM, it has to do not only with this market-oriented view of invention going to markets and then doing it through business, which normally is the way that innovation has been understood, especially with these capitalistic, let's say, top-down models that we're leading our countries on. We believe in this other focus, in a society-oriented innovation in general, including technology innovation, where we have knowledge, and knowledge has to go through users, application, and benefit through a sustained opportunity of having it. It might be a business, it might not be a business. It can also can be done by practices, by a common culture, and there are different ways of making the knowledge that we have in our communities and our practices to go through users. With this, we have devised this definition of social innovation. We believe in this specific way of doing social innovation that has to do with participatory knowledge management. This is where all the knowledge that the communities, that users, the beneficiaries have is as valuable as the one that we're fostering in our universities. Also, this knowledge has to define projects, programs, and of course, public policies that might improve the level and the quality of life of all the individuals and their communities. So this is like a very broad definition of social innovation, but that has a lot of, let's say, nuances involved. In particularly, when it talks about, and when we talk about quality of life and level of life, we're not talking only on the economic space. We're talking on this freedom of choice that Amartya Sen has told us, the Nobel Prize, that he envisions that development, that progress should be measured not on how money do we have, but more on how much freedom do we have. And we means everyone. And this is the idea of the social innovation space that we're working in and the project that we're designing. What does it mean? That we have to co-identify the needs to satisfy. This is the beneficiaries are part of the design and the diagnosis of what is needed, the co-development of the solutions. In our space of research, we do the design of the proposals with the communities at hand, and the evaluation. We believe that we as academics or the government as a funding or even the companies are not the persons to give the evaluation to those solutions. The community needs to have a say on it, and they have to say what is the threshold that they fix or they propose as the one to be for acceptance from them and not only from our vertical view. And finally, a very important element is that for a social innovation to be, we believe that it has to be scalable. In this side, I will show you very briefly 3 of the projects that we are working on. The first one is called CAPAS, and it goes from the capabilities approach that Amartya Sen and Marta Nussbaum had put up front on the social landscape. And we work with different rural households in Mexico, 24, in 4 different communities. And with participatory methodologies, we work in the knowledge creation of the solutions. So they were able to understand what energy means in their lives. And from that understanding, to ask and to design which social innovations they needed. Technological, but with a social inspiration. And what was most important, it was that we were able to impact those communities through energy literacy. All the inhabitants of the households had a saying, even the children and the elders. So we could envision very interesting solutions, ecological, social panels, the social heaters, also these stoves, efficient stoves of wood using biomass, but they all had to do with the current practices of the persons in the household. And by the true understanding of what energy means, and why do we know that the word true understanding? We gave them meters of temperature, humidity, noise, and illumination. And they were able to work with energy diaries every day during 4 months to understand what was happening in their household. And once they understood it, we worked with them hand by hand to design the solution that each household, rural household, needed. We also have this space on the peri-urban areas. One of our biggest challenges is peri-urban spaces, where, as you can see in these pictures, they are spaces that have a mixed, let's say, sense of self. They are rural, they are urban, they're very aspiring places, and they have a lot of informal commerce and a lot of informal micro industries in the households. So we work with woman-headed households. So I here loved also what was Anne-Marie talking about gender inequality and how to work with that being proactive and transformative. And this was the focus on this project. We work on home-based businesses, and we work with 3 different solar technologies in order to put forward business models that were attainable for these households, and also technology that made sense economically, environmentally, and socially for all these households. And finally, this is our last project. This is a work in progress. We're finishing it in September. And this is working on the solution to energy poverty. We understand that energy poverty is the inability to provide energy services to a household. And the difficulties that Latin America has, this project is Cuba, Colombia, and Mexico, and led by United Kingdom. They are the ones that are funding this initiative. What we found is also that we need a really high understanding of what energy means to well-being for the families. So we work on that. We did participatory workshops in these 3 years to be able to work with large communities so they could appropriate energy understanding towards well-being. And then with that in hand, we're working on solutions to energy poverty and energy vulnerability through making more resilient energy systems, but the resilience of the system lies on the persons, on their attitudes toward energy management, because infrastructure is too expensive to be able to foster it by our side. So we have public policies in place, not in place actually, but this we were going to have these workshops with policy decision makers so they can understand better where we see that money could be better spent in a different way of looking to energy. Understanding that energy is a means, not an end, and that energy management could be solidarity. Solidarity is like the key piece where we have households that can lend energy services from one to another, community spaces where energy can be used to power cell phones or even to, let's say, more basic needs, to heat water, to purify water. So that's what we're working on, where each community finds their way through this knowledge of what energy means to well-being, and then making them understand that empowerment and that community empowered through energy is possible, and that it doesn't necessarily have to do with looking for money or subsidies, but more on having a better harnessing of energy. Remembering that energy is basically that great partner that we have had as civilization since prehistoric times. So this is what we will working with. And finally, I would like just to insist that we don't need a transition, an energy transition. We need energy transformation. And it must be fair, it must be sustainable, but above all, it has to be inclusive, or we won't get there. We won't be able to transform our energy systems if inclusiveness is not the most important concept in it all. Thank you very much.
Thank you very much for your presentation, Carla. Very interesting. I think we're going to leave the questions until the end. So now we're going to continue with Laura Appenzeller. She is the Executive Director of the University of Illinois Research Park at the University of Illinois in Urbana-Champaign. And she's also the Assistant Vice Chancellor for Innovation. And so you are here, Laura. So it's open to you. Thank you. Welcome.
Thank you. Pleased to join you all. I'll be talking today about agriculture technology in the University of Illinois Research Park. Just give me one moment. I'm going to pull up my slides. I'm here in Champaign-Urbana, so I'll just start by saying a little bit about the University of Illinois Research Park. Was established back in 2001, so we're nearly 25 years old. And one of the core areas of strength that we've had has been around agriculture and technology, and that increasingly is overlapping with sustainability, which is why it'll be a focus of my discussion today. So come up. I apologize for the technology glitch there. So a little bit about the research park here in Champaign-Urbana at the University of Illinois Urbana-Champaign. There's 120 acres that once was fully occupied as a land-grant university by our College of Agriculture. And at that time, in 2001, we started transferring that property to become a technology park. It had an aim of economic development. So we wanted to both create a location where startup companies could thrive and commercialize the technology out of research and our student innovation at the University of Illinois, attract corporations who would work with our faculty and would work with students and create jobs in our community, and then increasingly work on translational research as well. Presently today, we have more than 2,000 employees and a very large concentration of students who are working in an experiential learning atmosphere where they're working in a mixture of the startup companies and large companies, and a lot of programming that supports a community of innovation with constant activities and lifelong learning as well. Our incubator is one of the places where that innovation takes place, and it is called Enterprise Works. It is a 43,000 square foot incubator, and it houses both laboratory suites and offices where we have many startup companies, and ag tech is one of the most thriving areas, including work that we've been doing in bioprocessing as a new emerging area of bio-based feedstocks. That's within this area that is the research park. So as I'd mentioned, it's an overall acreage of land that's quite large. It's 200 acres on the south side of the campus, and it's grown over time to now have 19 buildings. Ag tech, as I've mentioned, is one of our closely watched areas that we've been thriving to grow, both at the strength of engineering and agriculture at Illinois, that we think we can become a destination and leader in creating. We have many large corporations that are co-located here with us, and that's been an important area for us to grow and thrive. One of the employment options that we have is that students work across many disciplines, freshmen through PhDs, in part-time roles all throughout the academic year, and the companies either own that IP, or in some cases, these are students who are working on their own startup companies and creating a company themselves with their own IP. Some of the companies that I just thought I would highlight include John Deere, which does a lot of work in sustainability, in particular in advanced sensing. So how can there be more precise delivery of nutrients? And that's using new technology to do that. And amongst also digital platforms that are being connected here. And our Center for Digital Ag is one of the academic areas that overlaps with this type of work as well. They also work with startup companies, and I'll highlight too, there's actually been a recent investment in this company that came out of the University of Illinois by John Deere, and it's called Habitaire, and it is looking at how do we more accurately be able to assess carbon credits that are changing farming practices across the world using computer intelligence, satellite imagery, and also doing predictions of yields. So it's a good example of a corporate partner with a startup company. Another company related to the Center for Digital Ag that has partnered with John Deere is EarthSense, using robots to be able to now plant cover crops between rows of corn in a way that reduces labor obligations that might prohibit that type of activity, but also do that type of activity at scale and cost effectively, in addition to being able to do rapid phenotyping of crops and to reduce, in some cases, labor that has caused challenges in Malaysia with palm oil by replacing that those labor practices with large robots that could take the place of otherwise work conditions that would be adverse to the employees. Another example of a large corporate innovation center is the Bayer Crop Sciences Innovation Center, where they are working on new trait development, and they are using a lot of engineering and data to drive that innovation. Some examples of the types of ways that they engage students in this work is talking about how we will feed the world in a sustainable way. This was a neat opportunity we had to host an escape room this year with Bayer as a partner and teach the community, our students, and our researchers in this place about the challenges that face the world and how you can use science and genomics to be able to overcome those challenges. Both of those companies came together to engage our students on an interdisciplinary basis this year through a hackathon. This was part of our week-long Ag Tech Summit and a great example of how machine learning can allow us to get to conclusions faster, and students of all disciplines, as I mentioned, can work together to be able to deliver early prototypes and to actually train many of our full-time industry partners on how to do things with new technology approaches, in particular with math and statistics. Another area that we have been able to make an influence on is a company called Nutrien. They bought a company called Agrable that was started at our incubator facility, and that company was doing a better job of tracking sustainable practices in farms that would be able to validate claims for consumer products goods companies of whether the farms had actually adopted practices that could be truthful on labels. And that company was purchased for nearly $70 million by Nutrien. That company is now in our community at the research park and building out a large new facility that includes sustainable farming test ground that they can use as a place for not only farmers and growers to be able to interact with them, but also our innovation community. ADM has been a longstanding partner with us, so is one of the world's largest food ingredient companies and also producers of biofuels and other bio-based feedstocks. They've been a driver of our new tech hub that I'll mention. One of the startup companies that aligns with this work is called Boston Bioprocess, that recently relocated from Boston, Massachusetts to Champaign, Illinois, to grow a process that allows companies that might have done things at a bench scale in a research fashion of strain development to be able to get them closer to commercial scale and use our integrated bioprocessing research lab. So it's an example of a big and a small company coming together. And that was part of our success in recently being awarded $51 million from the U.S. Economic Development Administration to build out the possibility that plants can replace petroleum for new products like plastics or packaging or cosmetics, and also that we can use the crops that we cultivate right here in the Midwest for a new vibrant future in biomanufacturing that is a large production of jobs as well. That was possible because of many partners, two of which I just mentioned, University of Illinois Urbana-Champaign being in the leadership role, but also bringing together workforce partners, labor, venture capital, and other partners in the agriculture industry to make this vision possible. It's a little bit of scale up that we're seeing in Central Illinois with the funded projects to be able to create real job impact in our region. We also are working globally, so I'm happy to learn more from our colleagues in Mexico that have joined for the symposium today. We've had success in bridging international relationships, and I'll highlight two in agriculture. Genective is a company that started in France and in Germany. It's a joint venture between two large seed companies, and they relocated their headquarters to Champaign, Illinois. It's actually their world headquarters, and then also built out both their testing facilities for field station and greenhouses close by, about 45 minutes away, in a small community. Another company we recently located in the research park on the campus of the University of Illinois is GDM. It's a large company in Argentina that now has nearly 40% of the traits, around 40% of the traits of soybeans, and they've been working on how to make plants more resistant to different environments. They are the #1 producer of traits for soybeans in Brazil and in Argentina, and they're looking to grow in North America. And this is one way that they hope to do that, in partnership with a bigger voice and a bigger exposure by being at the University of Illinois with North America headquarters. We have major projects happening in translational research, and a couple that I'll point out. We have a greenhouse that is part of RIPE, which is a large research endeavor at the University of Illinois, led from the Institute for Genomic Biology, that is improving photosynthesis in crops to improve yields. That's been proved in crops that grow in Africa, but also applied to soybeans that would be more germane to our own geography as well. So it's a great example of things that we can do fast in the research park, including a new greenhouse for cabbie that was delivered in about 8 months. So being able to go from start to finish in construction is one tangible thing that we do in the research park with a different type of public-private partnerships. And cabbie is working on bioenergy solutions for the future and looking at new energy crops, as well as crops like miscanthus that could be used for packaging and other sustainable delivery in the future. We build out lab space. So this is one of the ways we're supporting the ag industry. We support new innovators through an accelerator. We bring people together to speak at a conference that melds together our academic community of faculty and students with startups, investors, and growers every year, 9 years running. And we give out prizes to local agricultural leaders. And it's one way that we try to support our community and bridge those producers with the activities here on campus. So that's a little bit about our activities, and I'd be happy to take questions, but hopefully that gives you an illustration of some of the ways that we can create economic impact with corporate partners, startup innovation and entrepreneurship, and engagement with our community to have a lasting economic impact. Thank you.
Thank you very much for your presentation. It looks very exciting on everything you're doing there at Research Park, and well, you all been very good with the timing, so we have 5 minutes before we start the next presentation, and I'm just going to make a quick question, and we'll leave all the questions at the end. But I mean, you presented about agriculture, but is Research Park only oriented toward agriculture, or it's open to other initiatives?
It is not limited to agriculture. I happen to talk about that subject matter today, but we have jobs. The most common job sectors are in software and data analytics. So as we're here focused more on engineering, engineering is powering many things across the park. So we have companies like NVIDIA and Yahoo and others that are across the manufacturing spectrum. So from Caterpillar to credit card companies like Capital One or insurance companies like State Farm. So there are many. Agriculture and technology happen to be two areas that are colliding in a way that we've seen real economic impact and regional drive of jobs, where we can work with local partners and with our producers that are right around us. So I think it's really important just to think about, as a region, how can you create something that's an identity, that's a real attraction point for companies? And that really began around software and engineering, but those are so ubiquitous now that they touch many, many industries. And our startup companies come all across campus. So our biggest area of innovation in terms of technology disclosures comes from the College of Engineering. In particular, electrical and computer engineering has more disclosures than any other singular department. But in many ways, those are being applied to areas that do have an impact in fields like agriculture or sustainability. So we are neutral to the technologies, but just highlighting that this is one area where we've seen real impact.
Okay, thanks. And I also now have a comment that with one of the earlier presentations by Anne-Marie Hanson, about the sargassum, which is a big problem, and there's a lot of initiatives that are there to use the sargassum to do things. So we can go from a problem to a solution and use that sargassum. And it seems that maybe Research Park will be a good hub for starting some initiatives on that, I think. So I don't know, maybe.
Thank you.
Well, thank you very much. I don't know if Misael Sebastián Gradillo Hernández is here already, if he can. Okay. So now our next and final talk about in this session is from Dr. Misael Sebastián Gradillo Hernández. He's a professor from the Instituto Tecnológico de Monterrey in the campus in Guadalajara, and he's the leader of research of Ruta Azul, which is related to sustainability and climate change. And he works at the Department of Bioengineering Laboratory, in the Laboratory of Engineering Department. So if you're ready, Misael, please go ahead and share your presentation.
Hello, everyone, and good morning. Thank you so much for having me in this really nice forum. So I will start sharing my presentation right now. Thanks very much again for the invitation to present my work and my colleagues, my group's work. So can you all hear me, and can you all see the slides clearly?
Yes, yes.
Yes, we can.
Thank you so much. So yeah, I belong to Tecnológico de Monterrey, as it was just mentioned, I belong to the School of Engineering and Science. And my main role throughout the last few years has been to lead the Sustainability and Climate Change Hub or Laboratory, which is located in Campus Guadalajara. This is a brief presentation of myself. I'm still a young researcher. I pretty much started my research career maybe like 5 or 6 years ago as a research professor. And well, I hold a PhD in biotechnology innovation with specialization in agri-food biotechnology. And I also hold a PhD in education management with specialization in sustainability. And I'm currently the Associate Director of the Sustainable Technologies and Civil Engineering Department in Guadalajara. I just took this position in the last month, so I'm pretty new with this. But I have been working at Tech for the last 13 years, first as a teacher, and then in the last 5-6 years leading the Sustainability and Climate Change Lab, more dedicated to research. I was also at some point the General Director of the Environmental Protection for the Ministry of Environment and Territorial Development of the Government of Jalisco, which is the state I'm located in. And well, some of my research lines are very much focused on circular and economy and circular bioeconomy, basically just understanding what are the flows of waste in our region. We are the agro giant of Mexico, Jalisco. We produce there's 32 states in Mexico, and alone Jalisco produces almost 20% of the agro-food or agro industry is located in Jalisco. So it's a big producer. Of course, tequila is one of them. Jalisco is the almost the only place where for the denomination of origin tequila can be produced. So that's interesting and an interesting data, I think. And yeah, well, we work closely with all the agro-industrial sectors, agro-industrial ways to develop circular economy or circular bioeconomy pathways to transition towards sustainable development. For some reason, I don't know, something happened. Can you still see my slides?
No, we cannot see. Well, I cannot see them. I just see a black screen. Now I see you.
Yeah, same thing happened to me. Let me see if there was a problem with the computer. I will start over and just reshare the slides.
Probably Mr. Olson has your slides and he can show them.
Oh yeah, maybe he can help me because I don't know what's happening. They were sent in the last few days. I will try anyway, and let me try again. Okay, I think you can now see my slides, right?
Yes.
Yes.
Oh, thank God. Okay, so our laboratory started. Just as a brief summary. We started as I said 5-6 years ago with this laboratory. We started with a call through Erasmus and the European Union calling for create pairs of European and Latin American laboratories that could develop synergies and that they could all develop climate change centered laboratories, but very focused on their main areas, in their main areas in the region, in the main problems of the regions. So ours was obviously designed to be towards the agro industry. And we had this very nice exchange with laboratories from France, Spain, Brazil, and then some other Latin American, so France, Spain, and Italy, and some other Latin American countries to develop what would be kind of the DNA and the purpose of our laboratory, so kind of the design of this So our laboratory is, we call it a living climate lab because we're really focused or centered completely around applied research. All our research has been coming from the industry, the government directly, and we focus on regional challenges like the management of tequila vinasses, which is like a large issue across the state. But we obviously require the cooperation of the industry with the government to develop new policies. So we combine this with the development of human resources. We have master and PhD students focused on these projects that are always maybe co-advised or co-supervised by someone from the industry or the government. So there's always like a direct output of whatever research we do. There's always a component of climate change. That's our main focus. And of course, we want to, like, although we prototype many solutions or processes or models or different approaches in our lab, we always have an output or an outlet directly to something that will really have an impact in our region. So there's always technology transfer. This is just some of the roadmap of the last 5 years and how we've been working with municipalities, the European Communion, some of the biggest tequila producers, some of the biggest blueberry producers, Cemex, which is the main producer of cement, and now we're developing circular economy pathways to valorize construction and demolition waste. Primex, which is a British and Mexican company which develops anaerobic digestion installments to valorize organic waste, and how we've extended with some good collaborations with some great universities in the last few years. So these are some more of our colleagues, and I'm going to start now talking directly of some projects that we have. And please let me know when I have maybe 2 or 3 minutes before I have to finish. And so we are very closely located to one of the main rivers in Mexico, which also happens to be maybe the most polluted. It's called Santiago River. It crosses the metropolitan area of Guadalajara, and it goes crosses 2 states to finally reach the Pacific Ocean. Unfortunately, it is highly contaminated with industrial, municipal wastewater as well as agricultural runoff, and therefore the water quality is it's very bad. But there's been some efforts in the recent years to kind of understand the problem and develop policies accordingly. And that's something that we've been working very closely in collaboration with the government. So we've strengthened the monitoring system. As you may see some red and yellow dots on the basin of the big gray shade is the metropolitan area of Guadalajara, which is the 2nd largest city in Mexico. And we've, as a team, we developed an approach to relocate. The red ones are from the federal authorities, and the yellow ones are from the state authorities, and they were kind of uncoordinated. So the first thing we did with them is just to establish a way to coordinate so that we don't have duplicated efforts and duplicated use of resources to kind of, because they were like just doing it because they're obliged to, being such an important river. They were gathering data, but they weren't checking like how the efforts could really give us inform on what actions should be taken. But we first realized that we were making redundant efforts between the 2 authorities. So that was our first approach through his research, through a paper, kind of show how we can optimize the coordination between these authorities. We made a specific focus on how to understand the land use within the area. There's, as you can see, yellow on the left on the right-hand side, which is mostly agro-industrial. That's the most agro-industrial part of the state. And then in red is the city, and then in green, the forested area. So the river crosses from right to left, crossing the metropolitan area of Guadalajara, where it gets most affected. But then it has a natural attenuation of pollution in the forested area. So we started by understanding all the parameters that were being measured throughout the last 15 years. And we developed a water quality index to communicate water quality to society. So basically, they had all these measurements that normally mean not much to general society, like saying a biological oxygen demand of 300 milligrams per liter is normally not like so easy, so straightforward to people. So we developed a methodology which was published in Ecological Indicators Journal to develop site-specific or ecosystem-specific water quality index according to the history of the river and its specific location. So now we can communicate water to society in a scale from 0 to 100 through a very robust statistical approach that we use to develop the index. So this is something that's already being done. This is how water quality is now communicated, so people can actually click on the different points and see what's the rating on each of them. We also developed this site for the government. So that was part of our work to kind of find a way to communicate an index, but develop the index, but also find the best way to communicate the index. And now we've been recently making some more efforts, because we know that water quality monitoring can be very expensive, but we can use AI, we can use machine learning to reduce the expenses, to reduce the number of parameters needed to calculate the water quality index, to reduce the time and resources needed to monitor water quality, to extend the water quality monitoring to additional points with the basin. If we can integrate artificial intelligence and machine learning. So we started testing our observations to develop some predictive models. Models such as multiple linear regression, generalized additive models, logistic regression, and these were all very helpful. At least they were like with less parameters rather than using 17 that were required for the water quality index. For instance, the logistic regression model was able to predict in 93% of the cases just with 12 parameters. So we can reduce the measurements of 5 parameters just by using logistic regression, which can classify water into 5 categories according to the scale that we saw before, like bad quality, medium quality, good quality. So that was one approach. And now we're developing a sensor for the water quality.
Misael, do you have a couple of minutes?
Okay, I will soon finish. Thank you so much. And we're developing a sensor to measure these specific 12 parameters using IoT services, artificial intelligence in IoT services, so that we can predict in real time with less money, less parameters, and we can extend and inform and take more rapid decisions. So in general, as the last slide, I would say that this is building up to a decision support system. We're now incorporated automatic systems for water quality monitoring that we're developing, instrumenting that, so that it's not only the formal monitoring points, but also some prototypes that can be moved around, that can flow through the river, that can detect in real time discharges, that can be very cost effective since we're reducing parameters. We're also developing a way to communicate better with the platform, not just the water quality, but all the activity in the basin, land use, industrial activity, information about health of the population. We're also establishing the basis for citizen monitoring of the water quality index. The community is taking a very active role into finding their own devices to measure water quality, because sometimes they don't trust in the government. So we're developing protocols for citizen science, and we've recently published a paper on that, on how we can actually take the data that is produced by the community to add it to the official data and check and maybe validate data together and like combine these efforts. And yeah, that's kind of where we're at now, to establish like a more robust monitoring. And this includes citizen science, artificial intelligence, machine learning, and development of prototypes to measure water quality in real time and make better and informed decisions. That would be my presentation. Thank you.
Thank you very much, Misael. I think we had a very interesting session covering three, but four key issues about sustainability. So we had energy, agriculture, climate change, and water. So I think this is really interesting, important, and for creating the networks between the people attending to this seminar, I think this is really good. Also, we heard that creating knowledge is very important. We saw that from two of the presentations, and from one of the presentations, that creating innovation to actually implement some of the stuff is really important. If there's questions, please put them in the QA section here in Zoom. And so we have a question for Dr. Carla Sedano. Says, thank you, Professor. Could you help me understand how your project for providing sustainable energy can really work in a large-scale environment, given the cost of limited time to achieve the goals?
Yes, of course. Thank you. Great question. First of all, to be able to work with communities, we require effective contact in the communities. So that shortens the time of involvement with the community. So that's like one of the main elements, to be able to have a trusted partner in the space, so things can go smoothly and work like in great collaboration. So that's one of the first, let's say, inclusion requirements for the project to make sense. And the second one is that we are working, and we hope to publish it soon, a financial model that includes externalities in technology management systems, where we account for social damages when you use other type of technology. We also account for environmental damages. And when you monetize all these negative impacts of not using sustainable energy solutions, then numbers make sense. But we're working on those models, so public policymakers might understand that incentivizing this type of strategies makes sense economically also, because we are showing the economic negative impact of not doing it. And finally, we're working with the social responsibility budgets of some companies to make them understand that it makes more sense sustainability-wise in the terms of institutional and cultural ways to do this type of investments in communities than, for example, giving scholarships to students and you don't have a follow-up of that scholarship. So we're looking for these companies that have to invest in social responsibility, but giving them this type of packages that will make this ecosystem where the social innovation has a greater impact and is finally self-managed by the communities.
And just to expand on the question, how has been your experience doing that? Has there been some success stories, or?
Well, we are
still struggling?
Yes, we're struggling. We have one local state energy agency that is willing to make the complete experiment because there's an issue. And we also have one major photovoltaic company that is interested in investing their social thingy. So we have the small ecosystem, and we hope to make that possible as soon as we finish the project of Latina with the final advances to be able to implement it in a larger scale. So I hope to be talking to you about this maybe in the Chicago Symposium next year. No?
Yes, that would be good. Okay, so there's some questions that, well, it says, thank you, Professor Carla. I think inclusion and evaluation are of the top priority to implement such projects. How important do you think it is to conduct and develop the project with a member in the community to understand the local perspective to uphold their social and cultural values?
It is fundamental. If you don't have persons in the community working with the co-design, the project will have a lot of challenges and obstacles, and it will be an apparent solution. So even though when we have persons of the community, sometimes it gets to be a apparent solution, we have to be very honest in this forum, but we have better opportunities of having a sustainable impact. So it is fundamental. Without community involved in the design and the whole process, we don't think this can be feasible. And our partners in Mexico, for example, we have a lot of technological universities that are aimed to those isolated communities. So we can make a very beautiful partnership, UNAM, local universities, local communities, and big companies and government working together in these scalable micro projects.
Thank you. We have a couple of questions from the last session, but I think they are pretty good. I think Laura can probably answer them. One says, I'm going to read both of them, just so you give a broad response, Laura. First one says, I know University of Illinois works closely with large AG companies, Bayer, Pioneer, etc. Are the AG products and robots done with the help of AG or University of Illinois and your researchers independently? The other one says, I'm curious about what's been done together with sustainable construction, habitational complexes or commercial with agriculture. Many land consider green areas or for agriculture are treated for construction. Will you have any articles related to that impact? Maybe that you don't know, Lara, but can you give a general answer for both questions?
Maybe I'll start with the first question. I know we're over on time, so I'll try to keep it brief. The first question may relate to how do we keep independence of our seed companies or corporations who are pursuing innovation and keeping that independent from research conclusions or research influence that might occur with our faculty and departments on campus. Those activities really are separate. So it could be that a corporation is seeking to do sponsored research or some sort of formal engagement with our faculty and departments, but that's separate from their operations that would occur in the research park. And our faculty are free to publish things that may be in contrast with the results of their own specific industry insights or what their industry conclusions might be. And that has been certainly part of our history as well. I think both of them are pushing on each other. So it's important that we as a university listen to where industry is going. And in many cases, I can say from a sustainability standpoint, industry was talking more about what they were seeing as a trend in sustainability and where there were opportunities to grow that was pushing our university to think about new opportunities for startup companies, carbon credits, and other aspects of the pipeline, perhaps before we knew it ourselves. So I think it's important that there's a two-way conversation, but there's also a protection of intellectual integrity and research integrity, that we don't feel undue pressure because we're working with companies on job creation or economic development, that has to influence in some way the work that we're doing as researchers. So I just wanted to emphasize that those two things can coexist. The second on building materials, some of that might exist in terms of LEED certification or sustainable practices like solar, or the way that we do landscaping or other aspects of our construction. I will mention one startup company in particular that has affiliation to the University of Illinois, is a company called Corn Board that came out of the University of Illinois that is turning corn into a replacement for wood as a both construction material, and interestingly, their first product was creating skateboards to prove the durability of the wood. So an example of building materials. And I'll stop there. Thanks so much for inviting me.
Thank you very much. Thanks to all the three presenters. We have to move on, so thank you very much for your presentations.
Wonderful, wonderful session. Thank you so much, Dr. Cristian Appendini, also for your moderation of the session. Next block will be moderated by Dr. Luis Mojica. Very importantly, Dr. Mojica is an alum, University of Illinois, Urbana-Champaign, but also very important, he's a very successful researcher in Mexico working at CIATEC, this research center in Guadalajara. So Dr. Mojica, please go ahead with the next session.
Thank you, Dr. De Mejía. Good afternoon, everyone. I will introduce our next speaker, Andy Mitchell, MBA. He's Assistant Vice Chancellor and Director of Sustainability at the University of Chicago. Welcome, Dr. Andy.
Thank you, Dr. Mojica. I hate to disappoint you, but I am not a doctor. That's okay. I'm very happy to be here. Muchas gracias. Estoy muy feliz de estar aquí. My name is Andy Mitchell. I'm the Assistant Vice Chancellor for Sustainability at UIC, and I'm really happy to represent UIC with this very impressive group of people. I think noteworthy that I am not a researcher. I've learned so much from you all today, but my role at UIC is really more of a practitioner. I work under the organization of basically campus operations. And although I'm sure many of you are familiar with UIC, others certainly are not or have not been to Chicago before. So I want to give you just a quick overview of our campus and of how we're different, certainly than our colleagues down in Urbana. Let's see, can you see my map there?
Yes.
Okay, so I'm zooming in. Oops, not there. This is downtown Chicago. And so for those that have been, all your Sears Tower and buildings, these are all right here. And we at UIC, we're just about, 8 or 10 blocks away over here on the very near southwest side. We're a big university, certainly by any standard, but by Chicago standards, we're the largest and only public research university in Chicago. We take up about 35 or 40 city blocks of a very urban area. So we're very constrained. We've got neighbors close in all around us, including these interstate highways. But on those 40 or so city blocks, we have over 200 buildings and 244 acres. We have 2 central plants, 2 power plants, 2 stadiums, 4 large swimming pools, a hospital, and over 5,000 trees that we manage. So we're certainly keeping busy in that regard. What I'm going to talk about today is implementing sustainability at UIC. So again, my role here is one of operations. It's one of planning. It's one where we take what we learned from all of you and the research that you're doing, and we apply it in practical terms to the operation of our campus. So a little bit about me. I'm pretty new to higher ed. I come from the private sector and from government, and have worked on energy efficiency projects, mostly in commercial institutional buildings for the last 15 years or so. My background is in an undergraduate degree in environmental studies, and then I augmented that with an MBA. I'm also a certified energy manager, so I kind of understand the engineering that you all are working on, but I'm not an engineer and I don't want to misrepresent myself. In terms of an agenda, what we've done at UIC is recognize that because of the size of our campus and the people involved, we need to make a plan in order to effectively implement sustainability on our campus. So noteworthy too, I mentioned the size, but in terms of population, on a given day, we have about 30 or 35,000 students, 15 to 17,000 employees. So we're a 50,000 person community. Getting that many people oriented in the right direction to do the same things is difficult. So our climate commitments are what guide us there. It's, I think, admittedly, a very fundamental, a very simple way to break down what we want to do as a university. The goal is to be carbon neutral, zero waste, net zero water, biodiverse, and transformative scholarship. So what I'm going to do here in my 10 to 15 minutes is just take you through some of the work we've been doing historically on those 5 commitments, and then what we're looking to do in the future as we implement an updated climate commitment action plan, which we should have out later this fall, which is a 5-year plan to to implement those 5 commitments. So I won't go through this history in detail, except to point out that UIC has a really strong history of sustainability going back to 2007. This was a time in higher education in the United States and internationally where sustainability in practice was moving from the classroom and from the research labs and into operations. And UIC was certainly a leader in that. We had our first climate action plan in 2009. These commitments came in 2016 with an updated climate action implementation plan in 2018, the recognition being there that we need a plan that's more actionable, more practical. So not just let's be carbon neutral, but like what are the 10 things you're going to do to be carbon neutral this year, next year, and in the next 50 years to meet our goals. Up to and including last year when we added a 5th climate commitment to integrate sustainability into curriculum. I think noteworthy that the sustainability concept and infrastructure is so different at UIC than it is at Urbana that they often don't even make great points of comparisons. It was great to hear earlier from IC and the work that's happening there. But sustainability at UIC is, at least for my purview, is focus on operations and on campus. There's some really great research happening, some great community involvement from some of my colleagues, and maybe for future conferences we could focus on those. But okay, so for now I'm going to go through these 5 commitments and give you a little look at what we're doing. So first up is carbon neutral. This is a really challenging situation for us. So UIC was built in the 1960s, basically all at once. It was occupied land. It was that neighborhood, primarily Black and Italian families lived here, and the city and state effectively took it over and built a university here. So we're very aware of that. A lot of those people are still in our community, and we do acknowledge the kind of duty of care we have to take care of the campus that we have now. So what you're looking at here is the ARC, the Academic and Residential Complex. It's one of our newer buildings. It's a LEED Gold building. You can see Sears Tower in the background there, and then that's University Hall off to the right, kind of our main admin building on campus. But ARC is one of our LEED Gold certified buildings. It's got some great features to it. I'm sure a lot of you are familiar with the engineering advances that go into LEED buildings, but just at a glance, you can see that it's built on an angle to optimize daylight harvesting and to prevent overheating in summer and capture heat in winter. If you look closely down in the bottom left, you can see that sort of rounded atrium. There's some beautiful classrooms in there. It has a green rooftop, and those sort of vertical fins you can see on there. Those again are optimized to shade sunlight in the summer and to allow light in the winter. In terms of being carbon neutral, we have some highlights, a lot to be proud of. We've done a lot of work with the space that we have and the resources that we have available. Remember, we're squeezed. We are stuck on a very small footprint in downtown Chicago. So when we look to be carbon neutral, we don't have the options that they have in Urbana-Champaign or any other more rural location that can consider things like these wonderful and massive solar farms that exist in that area. So we have to do the best with what we have. So we firstly look to efficiency. Let's make the buildings we have as efficient as possible. And that's a big project. These buildings, again, they were built in the 60s. They were built at a time when energy was very inexpensive and frankly not a priority. So that updating is one that we recognize is ongoing for many decades to get these buildings to an efficiency place where they need to be. In terms of generating, we've installed geothermal, which is really exciting. Of course, nobody can see it, it's underground. So we have also signage and interpretive information around campus to kind of point people down underground. And rooftop solar is another place where we have had some successes, but frankly, we have a lot more we can do. As I think people can appreciate here, while solar is great in concept, finding a roof that is flat and new and can bear the weight and is close enough to a connection point is hard. So of our 200 buildings, we can narrow it down to, I would say, probably 5 to 7 that are well suited for rooftop solar. And from there, we need to secure the funding, make a plan for care and so forth. So not easy. We also have new buildings going in. The Computer Design and Resource Learning Center is forthcoming. It will be a LEED certified building. And we partner with ESCOs. For those that aren't familiar, this is, I think, a really unique business model where if you take some of our larger buildings that would cost many millions of dollars to update into current energy efficient standards, where the state of Illinois or probably any institution wouldn't have those millions of dollars on hand, there are companies that will basically put that money up front to make buildings more efficient, to reduce the energy load and the cost of those buildings, and then share the savings with the client, in this case, UIC, so that UIC could start saving energy and money on day one, and then take some of that savings to pay back the initial investment to that energy service company. That's just one model, and there's certainly hundreds of permutations that have gone into that, and UIC has taken advantage of that in many ways. We have these central plants, which are very, very efficient by many standards. It's certainly more efficient to have 2 central plants than to have, say, 200 boilers or 10,000 window air conditioners. But they're old and they're aging, and they generate steam and chilled water, and they do that with natural gas. We also buy energy from our utility, and so that's a challenge to get off of that. It's not just a matter of getting a new central plant; it's a matter of changing all the infrastructure in the buildings. The tunnels that go between them would need to be dug up. So switching our campus over to a carbon neutral university would not be easy. It would be very disruptive and very expensive. So we're aware of that, and we're looking at ways to do it in a gradual, phased approach, where we can kind of fix the airplane while flying it, so to speak. I mentioned that we're constrained urban location, and then the market for solar is dynamic, and we are a state institution like many others, and sometimes we're not able to move at the speed that we would need to take advantage of market dynamics, let's say. But we do make progress. I want to point this out. This is an exciting thing. We have a program where students contribute to a sustainability fund. This is common to many universities. The program at University of Illinois Urbana-Champaign is actually, it's certainly one of, if not the largest student green fund in the world. So much respect to that program. We emulate you in many ways. Our program is smaller, but we still are able to allocate about $350,000 a year to student and community designated projects. And this is just one small one. Our grounds team purchased this electric lawnmower last fall, and they're kind of piloting it as a possible gradual transition for all of our groundskeeping work. But it's beautiful. It's very quiet. Smells great. You can just kind of get that grass cut smell instead of the gas exhaust. So a small example of us are transitioning into a carbon neutral university. So Zero Waste University, I mentioned earlier, our footprint is big, and the 50,000 people that come on campus generate a lot of waste. And so we work with our operations to establish a culture of zero waste. We have a lot of success to focus on. We've developed not just recycling, but also backup house composting. We have dining hall. We have several different food courts for the hospital, for the students in the community. We also have a student-run food recovery network that, rather than composting that food from those locations, they'll actually recover what's still edible and then drive it down the street to a homeless shelter and donate that food just sort of same day. And that's one of the benefits of being in an urban environment. We also do a good job recycling paper and cardboard, but we have challenges too. Like the global market for recycled plastics is very, I put in here, complicated and volatile. That's an understatement. It's very challenging. I think that the lesson that I've learned is that we can't recycle our way out of our plastic waste. We need to decide intentionally what we're going to bring on campus first and impact our,
you have 1 minute left.
1 minute, okay, all right, I'll keep moving. We had a great news story on our Zero Waste University. We have a net zero water goal, which is unique, particularly for our location on the shores of Lake Michigan. But we recognize that that while water's abundant now, we need to take steps to have a campus that creates permeable surfaces so that water can be captured where it falls and return to our arboretum and basically mitigate the heat island effect. We're part of downtown Chicago. We have 5,000 trees on our campus. We're a level 2 arboretum, and we need to get the water where it falls and use it so that we can cool not just our campus, but the surrounding area as well. Zero water is difficult because it's really inexpensive. So it's hard to make a financial case for that. Biodiversity is one that we've heard a little bit about today. Again, I mentioned that we're bee campus and tree campus certified. We have native plant habitats and a robust pollinator. And I'll just point out to our colleagues in Mexico, when we give tours and orient people to our campus, we point out that pollinator-friendly campus and acknowledge the multi-generational monarch butterfly transition from the forests of Mexico up through North America and back over generations. And we do intend for UIC to be an oasis for them. We have problems too. We have these beautiful glass buildings that are LEED certified, but also attract bird strikes. So what you're seeing here is the application of bird film. This is like a polka dot application that goes on the windows, and it only needs to be as thick as a spiderweb strand to deter those migratory birds from going into the windows. And it's been really great to see that implemented over time. Transformative scholarships are our last commitment, and that's really the integration of sustainability into our curriculum. And there's a lot of great programs that we're implementing there, including the Teaching Sustainability Initiative, which is like a train the trainer approach. So that's it in a nutshell. Thank you, Dr. Mojica. I'll hang out for questions after.
Thank you, Andy. We're gonna have the question at the end of the session. So we talk about how the University of Illinois at Chicago is facing sustainability. Now I want to introduce our next speaker, who is Dr. Alberto de Jesus Pastrana Palma, who is the Director of Innovation of the Autonomous University of Querétaro. Welcome, Alberto. Can you unmute your mic? Okay.
Yeah, thank you. Thank you very much. It was a great presentation from Andy. On behalf of the whole University of Querétaro, allow me to express congratulations. You guys are doing a great job there. There's a long way for Mexican institutions and Mexican educational institutions to actually be where you guys are. So congratulations. Well, let me share my presentation. There you go. Okay, a little bit about myself. Well, currently I am a professor in the College of Engineering. I'm also in the business school. I'm a computing scientist myself, who actually was slowly moved into the technology transfer issues over the past 10 years. So what I call an enthusiast of technology and technological development and innovation. And what I'm about to present you today is a little bit of what we have been doing in the University of Querétaro, in the Autonomous University of Querétaro, in order to harness innovation and intellectual property. Well, let me tell you a little bit about the Autonomous University of Querétaro, and actually what I believe are the most important strengths that we have in here. The first one could be probably the most important one, is that we are a diverse university. We have diverse research programs. Well, we have here from programs in medicine, engineering, natural sciences, nursery, informatics, and so on, and the business school, obviously. So we believe that's one of the most important strengths, is that we are diverse. So we basically cover what we consider all the aspects of the human being. So what we try to do is to solve different problems, and Querétaro is well, it's privileged in terms of its location in Mexico. We are located in the very middle of Mexico, in the very center of the whole Mexican Republic. And that's why we believe we have a strong industry collaboration. Probably the most important industries here are the automotive industry and the airspace industry. So we take advantage of that. Querétaro is got very important levels in terms of economic development in Mexico and also in innovation. So we take advantage of that, and we have lots of different agreements with different companies in Mexico, and we believe that's also one of those the most important strengths. Also, in the University of Querétaro, we have state-of-the-art research facilities. As I mentioned before, because we are a diverse university, we have many different research centers, obviously laboratories, and many other facilities that actually make our work a little bit easier. And that's probably one of the most important strengths. And obviously, we have experienced and renowned faculty. As I will mention later on in this presentation, we have more than 500 researchers in the national system of researchers. This is a very important institution in Mexico. The national system of researchers basically qualifies the level, the maturity of the research that we do, and we have 500 of those researchers certified into the national system of researchers. I will show you later on about this. And obviously we have a focus on sustainability and innovation, not only because of the different programs within the University of Querétaro, but because of the Mexican government, many of the programs in the Mexican government, we have what we call the national problems. So every grant that the government provides, and many of the industries are obviously interested in these problems. Well, they basically provide grants and money because as institutions we are able to solve problems such as poverty, water, environment, feeding, healthy eating, education, greenhouses, energy, and so on. So basically we are focused on this, and most of what I'm about to show you is because we solve these problems, and we therefore have a focus on sustainability and innovation. Well, this is a little bit of the history of the university, the Autonomous University of Querétaro, in terms of the national system of researchers. And this is one of the strengths I mentioned earlier. By 2018, we were about 300 researchers in these systems. And now we are a little bit more than 500. So we've been sustaining a growing in these terms, and we believe that's very important. I have to tell you that we have like different levels in this national system of researchers. For instance, we have a candidate level, which is a pre-level. When you are about to enter this national system, you undergo a different kinds of evaluations, and we have around more than 100 of researchers in this level. We have level 1, level 2, and level 3. The most important level right now in the University of Querétaro will be in level 1. We have around 300 researchers. And we have what we called the level 3, which is probably the most important number of, well, the most important level in terms of research. What it represents is that those researchers that have the most mature level in terms of innovation, and the ones that are actually solving problems. They are probably the heads of the schools, on head of departments or research centers. Right now we are about 20 of them. And we have also the emeritus level, which are probably retired researchers that are in many ways keep contributing to the university. We only have 3 of them. That's a little bit of how we have been growing over the past few years. And let me tell you a little bit about the focus on this, on the research going on at the University of Querétaro. Probably the main focus, because of what I mentioned earlier, the industry, manufacturing industry right now in Querétaro is probably the most important one. And that's why we have a lot of engineers, a lot of technology developers, and in terms of researchers, 157. Also, we are focused on social sciences, humanities, education and psychology, natural sciences, medicine and chemistry. Those are probably the most important fields in which we are actually and currently working on. But probably the history, this story is not as happy as we would like to tell you, because by 2018, there was almost no intellectual property. No technology transfer, no royalties, no real support from private investors. It was a real problem, because we might be one of the most important universities in the whole Mexico, one of the top 7, top 8 universities in Mexico, but at the same time, we didn't have any intellectual property registered. There was no way to handle this. There was no structure. There was no technology transfer office. So it was a big issue. So we actually got here by 2018 in order to solve that problem. It was a big issue, as I told you. Probably most of the research was made public, you know. Of course, we had a lot of publications, journal papers, books, book chapters, and so on. But there was nothing that there was no strategy in terms of intellectual property. And we actually began by starting from zero. So let me tell you about what we did, share you a little bit of how we actually started in order to solve this problem. But what we focused at the beginning was to make alliances, international ones and national ones. One of the first alliances that we did was the World Intellectual Property Organization. It was very important for us to actually understand how was this problem being solved around the world, and how actually were the other technology transfer offices working. And so this was probably the first alliance. There is an equivalent to the World Intellectual Property Organization in Mexico, which is called the Mexican Institute on Industrial Property, INPI. We also got an agreement with them. Obviously, another university organizations, a national like ANUYES, and a very important one, the LES Mexico, is basically a licensing executive society. This licensing executive society is a whole network of technology transfer offices that actually help us a lot in developing a strategy to actually harness innovation and intellectual property. So at the beginning, what we tried to do was to understand who was doing what and how they were actually sorting out this very important issue of harnessing innovation and intellectual property. Also, we began by spreading the word, spreading the importance and relevance, obviously, of innovation. So we began by doing these one-day innovation conferences. What we did was to actually prepare specific programs for different faculties. So, for example, if we went to go to the chemistry faculty, we were to focus on feeding and food industry, which is probably one of the most important fields. And if we were for a change to the business faculty, we were focusing on entrepreneurship. So what we did was to actually try to create more consciousness around the university in terms of intellectual property and innovation. And I think it worked from the beginning, and we obviously keep doing this job over the past a few years. Also, what we did was to develop an online intellectual property diploma. This is completely free. what we do is to actually prepare this self-managed. It is completely self-managed diploma. We set up a website with all the materials. We have these kind of interactive videos that they actually stop at one point. They ask you questions. You can select all the answers, and you move on. This is working. This is actually working, and then we have many people that actually apply for this diploma. And we believe that the more we do this, the intellectual property issue will be much more sorted out. Obviously, we keep going with workshops. We have specific workshops. For example, this 25 workshop on writing an application for a patent. This is much more focused on researchers who actually want to write their own application. And obviously we have others that are focused on other different problems of the technology transfer process. For example, we have another masterclass on valuation of technology, which we believe is one of the most important issues, but because we could have a technology, we could apply for a very interesting patent on that. But if we do not know or have an idea of how much it values, definitely we won't be able to negotiate anything with the industry. So we believe this is one way to go in order to sort out the problem. Other things that we have been doing are, for example, what we call the Detonate program. Detonate will be the English word for detona in Spanish. We call it like that because what we want to do is to go from the idea, the initial idea, into actually a real business. Obviously, in the middle, there is a lot of intellectual property things. There is a little bit of trademarks, for example, maybe patents, maybe some copyrights and so on. So we actually provide all these coverage for the students. This program is only focusing on students, and we will be having the second edition of Detona this 28th of August. So we are actually organizing the whole stuff right now. And we believe that the last year was actually quite successful. We have many participants, many different enterprises. And what we believe in this year is that we are actually going to achieve a larger number of different initiatives in terms of entrepreneurship, and you are all invited, of course. So in terms of results, by 2024, right now, at the middle of 2024, we've been able to actually grow the number of approved patents, utility models, industrial designs. In Mexico, the process of actually applying for a patent is a little bit larger than in the US, but it's quite the same. It's just a little bit slower. But what we believe is that is actually working. We now hold a portfolio of different patents, utility models, and industrial designs that will be one of them, for example, is being negotiated at the moment with a pharmaceutical enterprise. And we believe this is what actually is in the future going to allow us to negotiate royalties for the university. Right now, we believe we are not like we were in 2018, but we need to actually go a long way. There is a long way to still go in this intellectual property and technology transfer problem. We have 32 different applications in process. We also are working on copyrights, literature work, computer programs, databases, music. We still register on that, and we believe this is also a way in which we could actually get some benefit for the institution. And last but not least, we want to talk about the trademarks, the university trademarks. We produce many things in the university. One of those is milk, water, different biotech products, different pharmaceutical products. Obviously, we have the artistic groups. We are basically providing them a lot of advice in terms of how they can actually have a correct strategy in terms of trademark. As a conclusion of this, we believe this is not only teamwork, but also network. Why we say this is because teamwork is because we have a very strong teamwork in the university right now at the moment. It's like 10 people that are handling this whole story that I already shared with you, but there is also network. It's outside the university. We have a lot of alliances with different organizations that are actually helping us to keep on this work. And this is what I would like to leave you guys with. Is very important in terms of harness innovation and intellectual property to have teamwork and network. Thank you very much. This is it for me.
Thank you, Alberto, for this great presentation. Now I'm gonna introduce our next speaker, but feel free to make questions in the Q&A tool, and also there is one question that maybe Andy can respond directly in the Q&A, just because we are behind schedule. But I will introduce our next speaker, Dr. Jenny Miguez, who is Associate Professor at the Civil and Environmental Engineering Department at the University of Illinois at Urbana-Champaign. Welcome, Dr. Guest.
Thank you very much. So, gracias, Dr. Mujica, y gracias por la invitación. Hopefully you can see my title slide now. Is that right?
Yes, we can see.
Yes.
Okay, wonderful. All right. So, so I want to start and talk a little bit about revisit something that Madhukana brought up. So I'm also with I'm a faculty in civil environmental engineering and also the associate director for research for our Institute for Sustainability, Energy and Environment. So I work under Dr. Kana at the Institute. And the Institute, as Dr. Kana mentioned, has a three-part mission. And so I help lead the actionable research on the left side here. And a key feature of our research portfolio is interdisciplinarity. So it must be collaborative projects from across multiple departments. And so what I'd like to do is give a specific example of what one of those large-scale projects looks like, and then an example from my own work of kind of this integrative tissue, this that helps establish connections from across different researchers. And so if I come back to the example that Dr. Kana used, which was at one time CABI. So CABI is the Center for Advanced Bioenergy and Bioproducts Innovation. This is a U.S. bioenergy research center. There are 4 of them in the United States. And CABI has been funded over 10 years at about $260 million. It includes, at any one time, over 200 faculty, graduate student, and postdoc and technician researchers. And University of Illinois Urbana-Champaign is the center or the headquarters of it, but we have partner institutions across the country. And there are 3 main themes for CABI. So it's a highly integrative project or center. There's feedstock production. And so here they work with, in particular, miscanthus, sorghum, and sugarcane, and working to develop new lines of these crops that are more environmentally sustainable, but also produce target products within the plant. So there's a lot of crop sciences, plant biology, agronomics work going on in the feedstock production. And then they actually hand off that material to conversion researchers. And so we have on campus something called the Integrated Bioprocessing Research Lab, which is a pilot scale biorefinery. They actually take the crops in and break them down and convert them. And we have lots of facilities for synthetic biology and conversion research, such that researchers can develop new kind of strains of different target microorganisms, yeast and bacteria, to produce specific compounds, so that these now yeast can, for example, can take in sugar from the plant and produce a very specific product that is relevant to the marketplace and is currently being produced with fossil fuels. And then the third theme or third thrust here is sustainability. And the intent of sustainability is to advance this system while enhancing the global environment, making sure that solutions are equitable and improve equity across the value chain. And so the sustainability research includes everything from plant soil microbe interactions in the field to understand greenhouse gas emissions and things like nitrous oxide, up to the biorefinery design, which is what I lead, and to the marketplace, which is like what Professor Khanna's work focuses on as an economist. And so across these three parts, there's a very strong emphasis in collaborative research across different disciplines to advance the sustainability of biofuels and bioproducts. And so I have the privilege of serving at kind of one of these interfaces, and as I mentioned, the biorefinery. And so in the biorefinery space, our role is to, in particular, engage with researchers in feedstock production who come up with new plants with new capabilities. It could be improved phosphorus use efficiency, water use efficiency. It could be increased winter resilience, or a lot of our crops, they actually store oils, vegetative lipids in the plant that when they're not traditionally, they don't do that naturally. And then conversion researchers who have innovations in synthetic biology or catalysis or separations and so on. And we work with those other researchers to help them understand the implications of their innovation and how to move the technology forward toward a more sustainable outcome as quickly as possible. And so as we do that, I do want to touch on some language that we try and make sure we use, but one is this idea of goals. And so we as a center, but also as a society, we have these different goals that we might aim for. These are going to be broad, qualitative objectives. And so that's things like right now in the United States, there's a lot of focus on sustainable aviation fuel, and that's basically fuel to power our aircraft, our planes, that has a lower carbon intensity or lower greenhouse gas emissions. And so there are targets like we want affordable, sustainable aviation fuel or low greenhouse gas emissions. So to understand if we're moving toward that goal, we need specific indicators. And that might be the price per gallon, so dollars per gallon, or the carbon intensity per megajoule of the fuel. Those will be things that we can track to see if we're moving toward that goal. And then our government, industry, and even researchers can set specific targets for technologies. Like, let's say that industry has set targets for sustainable aviation fuel at things like trying to achieve $6 per gallon by 2030, or less than 80 grams of CO2 equivalents per megajoule by 2030. So these are specific values of our indicators with specific timetables. And so when we have something like this, we can start to understand, are our technologies helping us achieve that target? Is it feasible to achieve that target? And what should we prioritize in our research, development, deployment of these technologies so that we can target investment to be as impactful as possible? So when we sit down with collaborators who have an idea for a technology, or this could even be a policy or any kind of change to the system, we define the problem space. And this is our language, but it's the way we navigate these discussions with people from other disciplines. So we try and understand these kind of three categories. One is decision variables, like what's every choice they can make. So if we're collaborating with engineers, a lot of that time it might be like which feedstock, which plant they're going to use. It might be how they load their reactor, meaning how much material they send into the reactor. Might be how they configure the process, what material they choose. For the synthetic biologists, it might be what genes they turn on or off, and so on. We then have the technological parameters. This would be everything that they measure. So when they do an experiment in the lab or in the field, what is it that they're keeping track of, like the kinetics of the system or how efficient something was? If they made a material selection, we can estimate the material lifetime. Those are all important parameters. And then lastly are these contextual parameters. It's all these non-technological factors that may influence the design and performance. So that might be how the project is financed, or the full supply chain and its reliability, or how big the system's going to be, or local weather, things like that. So we work a lot to, we don't try and talk through our entire methodology initially with our collaborators. Instead, we just try and understand the decisions that they're going to make, the things they know will change because of those decisions, and all the places they could put their technology. And then what we do is we take that information and then we put it into this, what we call this quantitative sustainable design methodology or framework. And so we take all those values and we automate the process of developing a full-scale implementation of that idea. So if someone has an idea for a conversion technology, an engineer has a new catalyst or a new microorganism that can do something cool by taking sugar and turning it into a new product, we basically come up with the equations to design a full-scale facility that does that, that uses that technology. We also come up with algorithms or code, essentially equations, to then simulate its performance over its lifetime. So if we're going to build a plant that's going to run for 30 years, we want it to be able to simulate performance even if the feedstock changes in volume 1 year, or the efficiency of the reactor goes down over time, or something like that. And then we try and get to these indicators that we care about, and like costs and life cycle environmental impacts. And so we use analytical techniques called techno-economic analysis. That's how we get to cost. And life cycle assessment is how we get to things like carbon intensity. And so what this lets us do is we're looking at their idea, and we can get to a final place where we get to dollars per kilogram of the product they're trying to produce, or dollars per gallon of biofuel, or kilogram CO2 equivalents, which means the carbon intensity, or how much greenhouse gases were emitted per kilogram of the product or per gallon of the fuel. And so we automate this process such that we can evaluate every possible decision that they could make and every value that they could get when they go take that measurement in the lab, and all the places they could put this technology. And once we have this coded, basically we write this all as equations, we also want to acknowledge that we are making many, many, many assumptions, many assumptions. This is a technology that's never been actually implemented. It's maybe done in a small flask, and they're trying to understand if it's worth pursuing, such that if it worked at bigger and bigger scales, would it be a good idea? And so we do very robust uncertainty analyses where we're acknowledging that we're not sure about many of the assumptions that go into these models. And we do lots of sensitivity analyses to understand which assumptions matter and which assumptions don't. And where we head, what we try and get to when we've run this type of analysis are things like characterizing the sustainability indicators. So we have an idea, and we can try and figure out what its cost is going to be, or what its carbon intensity is going to be, or any other indicators they might care about, sustainability indicators. And we do that under uncertainty. We can identify sustainability drivers. So what is the key feature of their system that is most impactful for cost? Is it the feedstock they have to buy, or is it the catalyst and it degrading over time, or is it the electricity consumption, and so on? We set technology targets, and this is my favorite, but essentially we can say, all right, we know we're over here somewhere in terms of what the cost is. If we need the cost to get down to here, is where this target is, then what is the kind of my QSD input? What does my design need to be? What does my performance need to be? What do I need to measure in the lab such that I will know I've achieved the target price? We try and understand sensitivity so we can identify which parameters are really influential in our analysis and which parameters are not. And that can be really helpful because when we're thinking about taking a technology that's only been at this really tiny scale and predicting what it'll look like at a full scale, we have to make hundreds of assumptions. But in the grand scheme of things, maybe like 5 matter a lot, and the rest of them won't influence the results all that much. So it lets us focus our research efforts, focus our development efforts around those parameters that really matter. And then lastly, we call it exploring research, development, and deployment pathways. But we can run these different scenarios, these combinations to say, well, what if we develop the technology in this way and deploy it here? What if there's a different policy implemented? What if we integrate 2 different feedstocks instead of 1 or something like that. And we can characterize across these scenarios what are the relative costs and carbon intensity or other impacts so that we can focus our efforts around specific opportunities to advance the technologies. And so when we do this type of work, originally, when we entered this space and started working in the, for example, bioproducts, biofuel space, there are existing tools to get to things like cost and carbon intensity, but they will generally give you like an individual value. You put in, they're not designed to do any of these things really up here. It's mostly you'll get like an individual point. It won't be able to really answer the types of questions we ask about how to move a technology forward. And so because the existing software wasn't meeting our needs, we developed our own. And so this is one of the mechanisms or vehicles by which we have the most number of collaborations and the most engagement with researchers across the globe. And that is we've developed 2 open source software packages. They're freely available. They're on GitHub. They are in use by people all over North America, South America, Europe, Asia. And on the left, BioSteam is primarily for like biorefineries, but it's technologies that are more like kind of chemical engineering, but it's taking one thing and turning it into another. You can also use it for energy systems. And then on the right, what we call QSD-SAN, this is a technology more for sanitation and resource recovery. So a lot of my work, although I'm giving examples from biofuels and bioproducts, the other half of my work is around sanitation and human bodily waste, management of human bodily waste in low-income settings. And so we've done a lot of work in sub-Saharan Africa, India, China, and some other places. But we've developed these open source software packages so anyone, anywhere can evaluate a technology, simulate their own system, get costs and lifecycle environmental impacts, and so on. And so I'll end with just maybe a concrete example of one from CABI. So this is an example of a collaborative project with researchers with different expertise, including strain, which is the yeast strain design and construction and fermentation, computational skills, and actual scale up. And so they have this idea for how they're going to change a microorganism. They test it in a flask. They test it at a couple liters. They hand it off to our bioprocessing lab, and they test it at tens of liters. And then we design a full-scale system and say what it would look like. And we can get to these types of results where the red box and whisker plots are the results, and on the left is the minimum product selling price. This means how cheaply we can sell it and still make a profit. And the gray, in particular, the dark gray, is what this product, succinic acid, it typically sells for. So we're below that, which is a good thing. And then on the right is carbon intensity, where we're the red again, and we want to be low again. And we're well below fossil-based succinic acid and similar to some other. But we develop out these tools. We make it so you can visualize different analyses for the researchers to try and help them move their technologies forward. And that's where I'll end. But it was just to share that I see through the Sustainability Institute, we do support a lot of interdisciplinary collaborative research, and we also develop specific tools to support these collaborative endeavors to help generate insight to move technologies toward more sustainable outcomes. So thank you.
Thank you, Dr. Guest, for your representation, and thank you all the speakers for those great talks in this section. I think we are a little bit behind schedule, so we're gonna move. We have the Q&A tool that you can make any questions, and those are going to be answered directly by the speakers. So feel free to write your questions. Now I'm going to introduce Dr. Manuel Mas, who is going to take care of the section of integration and closing remark. Dr. Mas is a researcher at the al Instituto de Investigaciones y Economías Científicas de Ecosistemas Sustentables de la Universidad Autónoma de México, la UNAM, en el campus de Morelia. Welcome, Dr. Mas.
Thank you very much. I'm very pleased to be part of this effort. let me see. Okay, well, and also thank you for the opportunity to present this work. I'm going to focus on two topics, transdisciplinary and socio-ecosystems. Probably you have a chance to see my resume. I just want to highlight two things. I have a bachelor's degree in biology, but I have focused all these years in ecosystem ecology. And I have been coordinating for more than 25 years a long-term ecosystem research aiming to understand the structure and functioning of tropical dry deciduous forests in the Pacific coast of Mexico. And also I have been engaged during all these days, all these years within the International Long-Term Ecological Research Network. The international scientific community have reacted to the environmental crisis through important global research programs along all these several years. And recently, when I was invited for a presentation of how this ecology is leading, I was thinking, well, transdisciplinary is a key thing to go. And basically, we have been following these programs, participating in them with different group of people. And currently, we are working with this socio-ecosystem and transdisciplinary research programs. For many years, ecology was dominated for studies of 2 or 3 species, small in a small scales, and for 2 or 3 years. But the end of the 18th centuries, we have a big wake up by the president of the Ecological Society, Harold Mooney, and he mentioned one can review the last 10 years of our most important journals of ecology and do not realize that there is a severe environmental crisis. And at the beginning, we thought, well, I thought it was the problem of being reductionist or holism, you know. And certainly, when you analyze the approach in ecology, the way we conceive or we preserve nature, or we try to recover nature, or to benefit from nature, or to manage, exploit, or even value nature, we have different approaches. And an even more important wake-up call was during the Millennium Ecosystem Assessment at the turn of the century. And the people were, even that this program was specifically designed to improve the participation of social scientists with ecologists. It was perturbing to find that even the most involved in interdisciplinary research do not usually cross the territorial boundaries of these science fields. And well, since the beginning of the last century, Husserl pointed out this crisis of, particularly in the European culture and science, as a consequence of an unilaterally objectivism, rationalism. And so it seems that the battle between the realism and constructivism was more than just a few decades, it was more actually centuries. And basically, you know, this idea that the objects of knowledge is independent of the subject of knowledge, and the idea that we build reality based on our perceptions and empirical data. So basically, there are two ways to face understanding of reality, and as John Searle pointed out, there's an important difference between the construction of social reality and the social construction of reality. See, one thing is social reality as opposed to physical or biophysical reality that is constructed through our actions, our human biophysical actions, but also we construct reality in our minds, and we do so collectively. So One thing is reality itself, the one what we live in, and another thing is the epistemic reality, the one that we think. And the important things to understand is that we need both. It's not a battle. It's not a dilemma if we should do one this or the other thing. We need to do both. And but the problem is that we need to, in order to do it, we need to have this system thinking. And it was interesting that that Akov, the one promoted, a big promoter of the system thinking, we found that managers were more willing to embrace the system approach than and its implications than academics. And it's important because the conscious evolution of human it highly depends on how we understand the world. And because it guides and determines the types of solution we design and implement to deal with these environmental problems. So the way we think how works the world is critical for the solution of the environmental problems, and that's what we have seen along the talks. So for businessmen, it's much easier to understand that there's a real world where this information flows and feedbacks and rules of action and other things, but also there's a mental works of business people who try to understand this world and make decisions of that. And as Sterman says, the businessman says, we need both things. So it seems that there's three spheres of reality: the existence sphere that is based on what it is, what it was, what it will be. But another thing is what we believe is, or what we believe was, or what we believe will be. So there's the existence sphere and the epistemic sphere, and there's interaction between these two worlds, this real world, this mental world, and we call in different ways, the real, the national, the rational, the reproducible, logical evidence. So, but let's talk about this certainty as this intersection. So there's a difference of what we know, and there's a difference on error. So there's two different things. But decisions are based on perceptions, and that's what most people say. People live in the spheres of mental world. But yes, that's true. But also the results depend on the response of the system, and that depends on the real world sphere. But where is the spheres of the ethical world? And ethical in terms of behavior, because certain is not necessarily correct. Ignoring is not the same as not knowing, and what we do is not always honest. So we need another sphere here that is the practical, the ethical sphere, that where it is done, what was done, or what it is will be done. And as you can see, there's two more intersections that, honesty and the correct, the successful, the adequate, and so forth. And so there's a difference between unknown things, the error, and wrong things, if you want to say. And of course, there's a center of intersection here that we can call it on different ways. People think that's beautiful, the good, the virtuous, the happiness must be there, the good living. I like to put there the true, but sustainability, I think, is right on the middle. And philosophers, my friends, my friends, philosophers say, well, Manuel, all things you are saying all belong to this epistemic sphere. So, and the problem with that is that there are processes that deform or empirical perception of reality. And well, we don't have time to go through those, but the thing is that probably some of you may think that I'm with all the things I'm saying to you, I'm in this error part here. I hope some of you will think at least I'm certain, near to this certainty. But I want to be I want to be in the certainty. I'm sure at least I am honest because I believe what I'm saying and I'm saying what I believe. But what we are looking for is trying to be in that center. See, so it's important that linking this idea of three spheres of reality, we must recognize that there are important differences between physical system, ecosystem, and socio-ecosystems. So an ecosystem is actually a biophysical system, and a socio-ecosystem is a human biophysical system. And there are three different things. See, one system is very objective, the ecosystem are objective, but are they also sensible? Life sense the physical system, and humans are subjective. They not only are objective, sensible, but also subjective. And it's important to understand that we're talking about three different type of systems that are linked together. And I just want to point out that resilience, for example, belongs to this intersection of the correct, but sustainability is in the center of the interactions. So the difference between physical system, ecosystem, and socio-ecosystem, it is not a matter of level of scales, but of realm. So most of the system that we know, 99% of the universe that we know is a physical system. But when life appears, at least in Earth, see the ecosystem show up. It's not a level of analysis, but it's a realm, it's a biophysical realm. And socio-ecosystem is a human biophysical realm. All these levels of interaction and scales are interlinked, and it's part of that. All right, it's important to understand and to realize about this nested and hierarchical nature of systems. See, we talk about when we think in socio-ecological systems, we think either in a couple socio-ecological system or socio-ecosystems. And using this Pearl and McKenzie causal diagrams method, see, we usually think that there's an ecological system that interact with a social system, create a couple socio-ecological system. But what socio-ecosystem paradigm think is that is more nested and hierarchical. And this is important because if the ecosystem disappear, see, basically what we have left is in one case a social system, and the other case is a physical system. So we have the grown idea that if we don't we get rid of we don't conserve our ecosystem, we still can survive, and we can take a spaceship and try to go to another planet and everything. But so along all these years, I have been working with long-term ecological research, trying to evolve from long-term ecological research to a socio-ecosystem research. But that requires a change of epistemic processes. So working in terms of socio-ecosystem, we need to work in transdiscipline. So we faced that when we were moving from this long-term ecological research, and we have this our core research areas. We're trying to invite social scientists onto research, and they were not very interested. Until we realize that there are all other core research within the socio-ecological agenda that incorporate all these ideas, these interactions with in a more socio-ecosystem arena. So when we are trying to develop and delivering scientific information in response to these emerging needs, it's important to see the difference between understanding the system, making decisions using that understanding, and implementing those decisions. So one thing is science and technology, the other thing is a communication and delivery, but something that has been talked in this symposium, is about improving the outcomes. So basically, we need to move from curiosity-driven science to a more problem-oriented science and to results-based science. So we do very well on this area, but we're not doing very well. So we need to work on that. Sustainability science requires integration and accountability. So that's what transdisciplinary works. So through discipline and multidiscipline and interdiscipline, we push this epistemic sphere. But we need also to push the more practical sphere. So knowledge and learning that are generated in a daily practice is what transdisciplinary tries to rescue and include in a formal and more systematic way the process in a process that generates intelligence for the solution of the problem we face. See, but it's not an easy thing. We have encountered what I call false dilemmas. See, it seems that we need to choose between two different things when actually what we need to integrate both things. So basically, we need to understand that one thing is more interactions with its scientists, but also more plurality within people participating in the projects. So discipline is the solution of the problem from perspective of particular disciplines should move to the solution of the problems from several disciplines. But we need more interaction. So interdiscipline is the approach that to the problem and its solution from the perspective of complementary disciplines working together. So what is the difference with the transdiscipline? Well, transdiscipline is go beyond the academia. See, transdiscipline is where the intelligence behind the solution doesn't just come from science. So it's not a matter of choosing between rigor and relevance. We need both things in order to work together. See, and also it's important to understand that there's a difference between transversal work and transdisciplinary. See, transversal approaches working with different sectors of society, transdisciplinary approaches working with different sources of knowledge. So one thing is a development tool and the other is a epistemological stance, and we need both of them. So participating in transversal work is the only way to learn about this other knowledge requirement to real transdisciplinary research. So in summary, transdisciplinary is easier from ecosystem perspective. It must focus on the socio-ecosystem as a subject of study. It does not replace discipline. See, it requires the combination of transversal development processes. It's a matter of quality as much as matter of rigor and relevance. I mean, its quality is as much a matter of rigor as it is from relevance. It promotes epistemological pluralism. It takes advantage of the heuristical potential of the adaptive management process. Being subsidiary, facilitate the empowerment of local communities. It's a science of results that must be on the formation of mutual learning communities. So the take-home messages here is that sustainability is a socio-ecosystem property, and to achieve it, a resilient ecosystem are required, and innovate as much as possible as long as ecosystem integrity is maintained. And this sounds a pretty tough task, but we must to recognize that there's ground for that, and there's a whole ecological community working through those tasks. So everybody knows that when you transform the ecosystem, ecosystem integrity fall down. But it's not a linear thing. So there's what we call resilience. And we need to understand the mechanisms of resilience in the ecosystems, because resilience allow for different pathways of this, how the system behave in this ecosystem transformation gradient. So it's important to engage into ecosystem integrity management. And of course, we know that the more we transform ecosystem, we get more ecosystem services. except that we just understand that it depends on ecosystem integrity. So we can also both identify several paths for that. And so what we need to do is to work with well-being distribution. So basically, there's a different possibilities. Of course, the scenario A, where we protect and not use or not touch natural ecosystems, and scenario D, that we destroy everything. And of course, there's an opportunity to work with the ecosystem of this management, ecosystem integrity and well-being. So just a couple of slides in terms of integration and conclusion remark on this meeting. I think there's a common epistemic ground I have here along this morning. Yes, we should innovate as much as possible, but as long as it maintains ecosystem integrity. Yes, we maintain curiosity-driven science, it's important, but we need to promote more results-based science. And also, yes, we need to interdisciplinary research. We must move to a more transdisciplinary research. And finally, well, there's a great space for collaboration. We hear along the day that engineering pathways to secure water futures from Dr. Ana Barros, the interaction between nutrients, health, and environment issues, by Thomas Garcia. It was interesting to see engineering solution for agriculture from Manducana. Dr. Anne-Marie Hanson talk about the importance of incorporate gender issue and integrate an environment interdisciplinary research. Rocío de la Torre shows how connecting academic with industry through innovation. Dr. Carla Garcia Sedano talk about the importance of closing the present gaps, but through social innovation, incorporate and that leads, aligned with this transdisciplinary approach. Also, Laura Appenzeller talk about how achieving agricultural sustainability through technological innovation. Sebastián Gradilla talk about sustainability through circular economy. Andy Michael will have a talk on the hard work, the hard task and planning of implementing sustainability. It's not an easy thing. Alberto Pastrana mentioned how Mexican efforts to leverage intellectual property and innovation. And finally, we heard Jeremy Guest talking about charting technology development pathways and for circular technology. So we think we have either a common epistemic ground and also great space for collaboration. I congratulate the organizer of this meeting. I think it has been a great day. So this is basically what I want to mention to you. Thank you very much.
Thank you so much, Dr. Mas, for an integration and excellent, outstanding recommendations from your presentation. Well, this is the end of our symposium, and on behalf of the University of Illinois system, I must thank all the speakers for sharing their knowledge and all the participants for their questions and for being present. We have 165 attendees today. Be aware of seed funding next March. We will try to advertise it as much as possible, hoping we're going to be working together, researchers from the University of Illinois system and Mexican researchers. It's outstanding what we can accomplish together. I thank the moderators for their time and help. A special thanks to UNAM Chicago, Mr. Aldo Mora for Facebook Alive. Thank you to our champions of this symposium, people from the Office of the President, Timothy Kalin, Mr. Eric Olson and Nancy Salinas, both of them really good champions of I-MMÁS program. Well, I hope the part of the sustainability goals were accomplished today, and we accomplished our objective of this symposium to enhance strategic synergies among researchers in Illinois and Mexico, and to promote innovation in engineering towards sustainability. Muchas gracias a todos los participantes, muchas gracias a todos los mentores, las personas que nos ayudaron a moderar, muchas gracias a los participantes y a todos los que nos ayudaron a desarrollar este simposio. Deseamos de todo corazón colaborar, trabajar más en conjunto, la Universidad de Illinois, Chicago, la Universidad de Illinois Urbana-Champaign y la Universidad de Illinois Springfield. I hope we can collaborate con nuestros amigos, colaboradores en México. Nuestros mejores deseos a todos y seguimos en comunicación. Muchísimas gracias y hasta el próximo simposio. Gracias a todos. Hasta luego. Gracias, doctor Mas. Fantástico.